Hi everyone, welcome to Vedantu JEE English. I'm Diksha Kaushal, your chemistry master teacher, and I really hope so that your preparation is going really well. And in yesterday's, that means class, in the last class, we have done chemical bonding and coordination chemistry. That was a very high weightage topic, right? From those two chapters only, you can get maximum marks from inorganic chemistry. That means they are the highest weighted chapters. Now we are left with three more things, and one also we can also include salt analysis in inorganic chemistry. But salt analysis, the problem is salt analysis, maybe one or two questions can be asked from that, but you have to do a lot of hard work in salt analysis. I am not saying that skip that. I never, no teacher will tell you to skip any chapter, but here I am just telling you, right now is the time for smart work, right? So what you need to do, focus on block chemistry instead of salt analysis. After that, if you still have time, then you can go for salt analysis as well. Because if you're aiming for really like IIT Delhi, then obviously you have to go through everything here, right? Okay, chalo. So now, just give me a second. Okay. So guys, now today we are going to talk about D block and P block, D and F block and P block, right? Okay. Are you going to explain S block also? Are that's why would I explain S block? Yeah. Huh? Do you want S block also? Why you want S block? Ma'am, will you take GOC? Yes, I will take GOC. After inorganic chemistry, I'll take GOC also. Okay? Yes. Chalo. Now let us start the session without wasting any time. Firstly, let me tell you one thing, right, very clearly. If you feel that after watching this session, ma'am, will I be able to complete full block chemistry? See, block chemistry, they ask you questions from each and every single line. So I have already prepared the notes for you. I have concluded those things for you. So mainly we are going to focus on concepts also, the previous year questions also. We are going to do about 70-80 previous year questions today. 70-80 previous year questions. That's a big amount, right? And we are also going to see the in a very summarized manner, in a very fast manner. I will teach you D block firstly. After that, we will see the previous year questions of DNF block, and after that, we are going to see P block. In DNF block, they can ask you very different kind of questions. So I will prefer that because in DNF block you don't have that many exceptions, but you have a lot of theory, right? So if you really want to get like 100% marks in DNF block, then you have to also go through the previous year questions in details, because those questions, because they are on the basis of color, on the basis of oxidation state, the questions are asked that can be repeated as it is in your JEE Mains 2025, right? So firstly, let us see the summarized form of D block. So are you all ready for D block? Yes, everybody? Yes. The PDF will be provided to you guys. Don't worry. On the JEE Telegram channel only, the PDF will be provided. Okay. So if shall we start this? Ma'am, you are recording from Bangalore. I am from Bangalore. Yes. High five. Chalo. Now, let us start this. Now, firstly, to D block elements, right? In D block elements, guys, we have basically 4 series. Okay, firstly, as you can see here, the series are 3D, 4D, 5D, and 6D. Right? Mainly, they will ask you questions from 3D series. The trends that they will ask you will be from 3D series. The exceptional trends of ionization, energy, radius, they will be from 3D series. One question they can ask you about the electronic configuration. So you should also know the electronic configuration of 3D series. So I'll tell you in a very summarized manner, right? Now guys, in 3D series, how to learn this? You might have your own mnemonic to learn this. So I'll give you a simple thing, right? Saktiv, Karman, Fi, Ko, Ni, Ku, Jan. Okay, Saktiv, Karman, Fi, Ko, Ni, Ku, Jan. Right? This though you have to remember, right? Now, this is from 21 to 30, right? And you need to know all the electronic configurations, right? So, if you say that, ma'am, what is the electronic configuration of scandium, right? Now, how you will write? Saktiv Karman, right? I'm just going to write for these 5 elements. always there will be argon 18. Firstly, this is 21, this is 22, this is 23, 24, 25. Okay, so always what you're going to do, always there will be argon everywhere, argon 18, 18, 18, 18. After that, you will fill the electrons in 4s2, right? 4s2, and everywhere it will be 4s2, 4s2, 4s2. After that, you will have 20 electrons now. Now this digit will be filled in your d orbital. This is 3d1, this is 3d2, this is 3d3, this is 3d4, this is 3d5, right? But here we have one exception, in fact two exceptions, right? Chromium, we can see that if we write the full or like electronic configuration, it will be argon 18, 4s2, 3d4. But half filled and fully filled are more stable. That is why this electron will jump here and the electronic configuration will be 3d5. Okay, so that is the exceptional case here. That is the exceptional case here. If you want me to write, ma'am, please write the electronic configuration of other elements of 3D series, because see, they can ask you directly question on paramagnetism, dimagnetism, unpaired electron, magnetic moment, right, based on only this electronic configuration. Even the colored and non-colored, colorless compounds are, you can tell from the electronic configuration itself, right? So it's a it's like a free number, right? Just by the electronic configuration, you will have a variety of questions that you can solve. And these are in the easy category, right? So now this is 26, 27, 28, 29, 30. Now Saktiv Karman, Fico, Niku, Jan. Okay, Fico, Niku, Jan. Now here also the same thing, argon, 4s2, 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 4s2. And this last digit will be your 3D. Okay, so this will be 3d6. 3d7, 3d8, 3d9, and after 20, because this is argon 18, 4s2, that means 20 electrons we have already filled. We are left with 10 electrons, so we are going to fill those 10 electrons here. It is going to be 3d10. Now, again, the second exception here is copper. So copper is going to be argon 18, 4s1, 3d10. Because half filled and fully filled are more stable, that is why you will have two exceptions here. One is chromium and one is copper. One is chromium and the other is copper. Okay, and the other is copper. Got it? Okay, so that was about the electronic configuration, right? Now, other thing is, this is your 3D series, this is 4D, 5D, 6D, and this will lie from scandium to zinc, right? Okay, got it? Now, next is electronic configuration. This I have already told you. Now, they will ask you either the electronic configuration of 3D series, maybe through some unpaired electron or something like that. But if they ask you any direct electronic configuration, then they will ask you for palladium, right? So for palladium, usually the electronic configuration of D block elements are NS1 to 2 and ND. So it will be N plus 1D. 4s2, 3D. N minus 1D. N minus 1D, 1 to 10. This is the general electronic configuration. But palladium is that D block element which have 0 electrons in the s orbital. Its electronic configuration, it's very important. Its electronic configuration is 5s0, 4d8. That is why this becomes very, very important. Directly they can ask you this, a simple direct question of D block, right? Okay, rest of the things I have already told you here. Next is the series and their atomic number, right, and their electronic configuration. As you can see, in 4s you will always have either 2 or 1, either 2 or 1, either 2. But here in case of palladium, you have 0 and 10. That means this is 5s0 and 4d10. Okay, everywhere else you will have either 2 or 1, either 2 or 1. So from this particular tables, so I have picked out tables from your NCERT. So from this particular table, what you need to remember, the configuration of palladium, right? Okay, got it. Now, next is your 3D series. Now 3D series is in detail in our syllabus, so they can ask you any exceptional trend here, right? So firstly, though, we need to observe this table in detail, right? So let us look at this table. First thing is the elements from scandium to zinc. Electronic configuration we have already done, right? This is when it will lose 1 electron, when it will lose 2 electron, when it will lose 3 electron, right? That means you need to, whenever you are taking out electrons, that will be taken out from 4s orbital, right? Next we have energy of atomization. As you can see, energy of atomization is not in a very good, like it's not a proper way it is decreasing or increasing. There is no as such pattern. It is firstly increasing, then little bit increasing, then decreasing, then also decreasing, then again increasing, then again little bit increasing, then again little bit increasing, then again decreasing, then again decreasing, right? So it is not in a proper order. So when things are not in a proper order, they are not asked to you, right? Okay, next is ionization enthalpy, right? Ionization enthalpy. Now ionization enthalpy is important for 3D series. Okay, though it's not a proper trend, as you can see, this is first ionization enthalpy is, firstly it is increasing, right? Firstly it is little bit increasing, then again decreasing, then again increasing, increasing, then again it is decreasing, again increasing, and again increasing, right? So it's also not a proper order, right? Then we have metallic and ionic radii standard electrode potential. Let me tell you in detail, right? Firstly, so let us observe the exceptional trends here, right? Okay, wait a minute. D block elements. Let us firstly see the exceptional trends that can be asked to you, right? Firstly, see those trends. So as you can see here, this is your electronic configuration, right? Now, very important thing here. Yes, this is your transition series. Wait a minute. Is this D block? Wait a minute. Where is D block element? This is not D block element. It should be here. This is your exceptions. Okay. Firstly, if you talk about the atomic size of 3D, this thing can be asked to you, that firstly it is decreasing, right? Firstly, so it is decreasing from scandium to manganese, right? After from iron to nickel, it is constant. From iron to nickel, it is constant, right? Here we are talking about the atomic size. Then after that, it is again increasing. So this thing is very important for you. Why this happens? This is because of mainly the inert pair effect, right? Because here we have, see, when we are going to this side, there are two effects that we have. First is screening effect, other is Z effective, right? So basically, why here the atomic size is decreasing? The reason is the Z effective. That means that effect which is decreasing. See, what is Z effective? Effective nuclear charge. When you have more attraction, this is nucleus, this is outermost electron. When you have more interaction, more Z effective, the size is going to decrease. That means here we have more Z effective. Z effective is increasing. Ma'am, Z effective is increasing throughout. But in case of iron to nickel, Z effective and screening effect will become equal to each other, as if these are two enemies who are fighting with each other, right? Here Z effective is winning. Here both, why the size is constant? Because both are in a tug of war situation where both are, for example, both are at equal power, right? Now, this is where size is increasing. That means here screening effect is increasing. Screening effect means this is your outermost electron, this is the nucleus. Screening effect, here you have the electron. If the electron has high power to screen, to protect the outermost electron from this nucleus, then the size is going to increase. Okay, that is why this abnormal behavior, this abnormal increase and decrease is important for you, right? Next is our lanthanoid contraction, very important thing, right? Next is our lanthanoid contraction, very important thing. That in transition elements, one more thing happens, that is your length. Wait a minute. Okay, that is your lanthanoid contraction. So what exactly happens here? Just give me a second, guys. Okay, so here what will happen? Lanthanoid contraction will happen. What is lanthanoid contraction? See, first you need to understand what is screening effect. What is screening effect, right? Your whole block chemistry is based on screening effect. All the exceptions are based on screening effect only, right? So screening effect is simple way, you have a proton, right? This is the outermost electron. In between you will have some other electron that are going to protect the outermost electron from the nucleus, right? When the protection is very good, when the screening is very good, we say screening effect is more, hence the electron will not be attracted, hence the size will increase, right? If the screening effect is very poor, these electrons are not able to protect the outermost electron, the size will decrease because the interactions will increase, right? Okay, so now what is lanthanoid contraction? What is inert pair effect? They are the same thing. Inert pair effect we call the same thing when d electrons are not able to protect, right? When any electrons are not able to protect, that is called inert pair effect. And what is lanthanoid contraction? When f orbital electrons are not able to protect the outermost electron. See, if you talk about the screening effect, then screening effect of f orbitals is poor, right? That is why d is also poor, f is even poor, right? So d electrons also, you will see throughout your p block that because of d electrons you will have exceptions in the d block. But when we talk in the p block, right? But when we talk about, see what will happen now. So for example, you have this 13 group, right? So what will happen? From here, from this period, you will have the addition of d orbitals, right? D orbital means d electrons. When d electrons will start including here, they will not be able to protect the outermost electron. That is why there will be so many exceptions in p block, right? What about ma'am f block now? Ma'am, what about lanthanoid contraction? What about actinoid contraction? That is same. Okay. When the 4f electrons or 5f electrons are not able to protect, right? Because they have poor shielding, the size will contract. That is why it is called contraction, right? So when it is due to 4f, that is called lanthanoid. When it is due to 5f, it is called actinoid. Now, 4f has, like 5f has even poor shielding effect as compared to 4f. That is why actinoid contraction is even stronger as compared to lanthanoid contraction. From these 5-6 things, I have already told you like 7-8 questions of your JEE mains, right? Okay, so based on this concept only, you will get so many questions in your JEE mains, assertion reasoning questions, right? All these questions. Now, that's why we say that the size, if you talk about 3D, then you have 4D, then you have 5D series, right? Because of the lanthanoid contraction. Because what will happen if you talk about this thing, here, this is your 3D, this is 4D, and this is 5D. Now, guys, very important thing. In 5D, as you can see, lanthanum you have. In 6D, you have actinum. The F inner transition element are starting from this point, right? Actinoids are starting from this point. In between this, you have actinoids. In between this, you have lanthanoids. That means here you will have the addition of 4f orbital. Here you will have the addition of, wait a minute, let me write it here, 4f orbital. Here you will have the addition of 5f orbital, right? As I told you, 4f and 5f, because of the poor shielding effect of f orbitals, they are not able to protect the outermost electron. The interaction with the nucleus is more. That is why the size decreases. That means the size of this 5D series is going to decrease, because here all the other elements will have 4f orbitals. But in 4D, these will not have 4f orbitals. Got it? Here they will have 4f orbitals. Here all the orbitals will have 4f orbitals. Here they will not have 4f orbital. That is why here lanthanoid contraction will occur, and that is why the size of 4D and 5D will become almost similar. And any question can be asked to you. They can ask you zirconium and hafnium, right? Or any of this element. Basically, so they will ask you zirconium and hafnium only, but still you should remember that what are the elements of 4D and 5D. Okay, so you can go through this, you can learn this with the help of a mnemonic, so that if they ask you any other also, for example, they are asking you cadmium and mercury, why they have similar size? Similar size is due to lanthanoid contraction, right? Silver and gold because of lanthanoid contraction, right? Okay, this you need to remember. Got it, guys? Okay. Yes, bacha. So now that was about the 3D, 4D and 5D similar size. Only that page is very bright, other pages are not that bright, okay? Other pages are not that bright, okay? Now, let us see this thing. Acha, very important thing here, ionization enthalpy. Just remember V Coni. V Coni. What is V Coni? V Coni. What is V Coni? V Coni is the size, how it is increasing. The ionization energy has a very, as I told you, it has a very unstable pattern. It is increasing, decreasing, increasing, decreasing. How to remember that? Now, what to remember? That what you will have in place of V, Co and Ni, you will have different sign. Others will have the same sign. For example, we know that down the group, see, whenever along the period size is decreasing, ionization enthalpy is increasing. Along the period, always this is a general pattern, that size is decreasing, ionization enthalpy is increasing. So that means ionization enthalpy should increase like this. It should be like this. So I am just drawing that what it should be like. Increasing, increasing, increasing. It should be like this. Ionization enthalpy is increasing along the period, right? It should be like this. I am saying just remember V, Co, Ni. So in front of V, in front of Co, in front of Ni, you will just change the sign. That will become your order. Okay, that will become your order, right? Okay, that will become your order, and it's a very, very important order. Ionization enthalpy, right? Then you have metallic character. Then you have metallic character. So in metallic character, what you need to remember, all the elements are very hard and high enthalpy of atomization and low volatility, except for copper, right? All the other elements are very hard, but except for copper, hardness increases with number of unpaired electrons, but group 12 elements, that is zinc, cadmium and mercury, show the exception. So basically zinc, cadmium and mercury, basically what will happen? In zinc, cadmium and mercury, you don't have any unpaired electron, right? You don't have any unpaired electron. These are all having fully filled d orbital. And that is the reason these three are non-transition elements as well, right? That is why these three are non-transition elements as well. Next, you have melting and boiling point. As you can see here, this I'll teach you. Just give me some time. This I'll teach you. Not here, right? Yes. Chalo. Now we have done the exceptional trends here. Now one by one, let's go and see other things, okay, from where the question can be asked, right? Okay. So see, block chemistry is a very big chunk of inorganic chemistry. It's endless, right? So that's why I have picked up some very, very important points specially for you, right? So now you have the oxidation state. From oxidation states, what they can ask you? First, they can ask you which is forming the maximum number of oxidation state, that is your manganese, right? From +2 to +7, it is showing the states. Chromium is showing the most stable state. The chromium is showing the most stable state as +3 and +6. Vanadium is showing +5 also, a very stable state. That is why it will exist as V2O5, right? Okay. So then we have scandium. It is only showing +3. Zinc is only showing +2 state. Copper is showing +1 and +2, where +2 is more stable. From here also question has been asked in your JEE means that why +2 is more stable, right? We will see that. Okay, we will see that in the questions as well, right? Now nickel is more stable in +2 oxidation state, cobalt in +2+3 oxidation state, iron in +2+3 oxidation state, manganese in +2 and +7 oxidation state is very stable, titanium in +4 oxidation state is very stable, and scandium is having only +3 oxidation state. So okay, so this is basically the more stable state that you will also find in coordination compound. Nickel, usually it is existing as Ni2 positive, right? Cobalt is existing as CO3 positive or CO2 positive. Chromium is existing as mostly Cr3 positive, and sometimes it also exists as Cr6 positive. So from the oxidation states also the questions can be asked. Okay, so once you go through this, I think you don't even need to remember this. It's a general knowledge of chemistry. You will yourself know that okay, these elements are existing in these particular stable state, because you must have seen those. Zinc, you will not have you seen zinc 3 positive, zinc 4 positive? No, right? So zinc is existing in +2 oxidation state. That is the most stable, right? Okay. Now next is about the transition element, that zinc, cadmium, mercury. These three are non-transition elements because they have fully filled oxidation, fully filled d orbitals even in the excited state. That is why they are non-transition elements. Then we have melting point and boiling point, right? Very, very important graph, right? Very, very important graph directly from your NCERT. What you need to remember here, that maximum, see, melting point is dependent on the number of unpaired electrons. So maximum unpaired electrons are in D5 configuration. Do you agree? D5 configuration has a maximum unpaired electron, right? Okay, that is the reason they can ask you just from these series that here tungsten has the maximum, molybdenum has the maximum, chromium has the maximum melting point among 3D, 4D and 5D series. This they can ask you directly, right? Now, due to stability in case of half-filled d orbitals, these shows comparatively high melting point. Till D5 melting point increases gradually, then after that it will drop. Firstly it will increase, after that it will drop. One more reason for high melting point and boiling point, this is unpaired electrons of D5 result in increase of the metallic bond. Okay, so basically because of more unpaired electron, the metallic bond is very high. So what they can ask you directly, which has the highest melting point among this series, right? Next is your melting and boiling point. As you can see here, chromium has 5 electrons, this has 5, this has 5 electrons. So many unpaired electron it has. That is why it is having maximum boiling points here, right? Okay, that's it. Next we have enthalpy of atomization. As I have already shown you in the table, that follows a very unsymmetrical trend. So metals of second and third series have greater enthalpy of atomization than corresponding to elements of first series, right? That means 3D series, right, that have less enthalpy of atomization, right? Effective nuclear charge decreases. What is the reason behind that? That down the group we know that new shells are getting added. So effective nuclear charge always it increases along the period, right? It will decrease along the group. It increases due to addition of 1 electron and 1 proton. Here it is decreasing because addition of a shell only, right? You are adding shells here. 1s, 2s, 3s, 4s, 5s, 6s. That is why it is decreasing down the group, right? As a result, unpaired electrons are more available for metallic bonding. So that means as the Z effective is decreasing, that means the unpaired electron in the outermost shell, they are not very attractive from the they are not getting very strong attraction from the nucleus. That is the reason their size is increasing and they are more available for the pairing, right? Okay, for the metallic bond. Okay, they are more available for the metallic bond. That is why metals of second and third series are greater enthalpy of atomization, right? Next we have atomic radius. As you can see here, atomic radius, guys, I have already told you that generally atomic radius will decrease along the period. Down the group always it will increase, but there are exceptions that we need to focus on, and exceptions I have already told you that how to learn size of the 3D series, right? Okay, now next is, here they are talking about atomic radius of 5D series and 4D series are equal to each other. That is because of lanthanoid contraction, that also we have talked about, right? Next we have ionization enthalpy. Here also ionization enthalpy is inversely proportional to the size. Okay, so if along the period size is decreasing, ionization enthalpy will increase, right? And the exception as well, we have discussed that what was the exception. Okay, we have also discussed the exception here, right? Firstly it was increasing, then it was constant, then decreasing. That exception we have seen, right? Not increasing, decreasing, the exception was V coni. Here we have discussed the exception V coni. Increasing, decreasing was the size. Here we have discussed, the firstly what you will do, it is increasing, but in front of V, co and ni, just change the opposite sign, you will get the trend here, right? Okay, got it? Chalo. Now here they are telling you some concept here. So concept we need to understand, right? So there are basically 2-3 kind of question in block chemistry. One is directly cramming based questions based on exceptional trends, but there also you need to understand what was the reason behind that. Reason is usually screening effect, lanthanoid contraction, actinoid contraction. Most of the time inert pair effect, these will be the reasons, right? But here they are saying that which will have more stable configuration, right? So if you talk about some of the metals show low first ionization enthalpy. If you talk about chromium, chromium is 4s1 3d5. So it is easy to take out electron from here, right? Because it is 4s1. But from chromium positive, it is very difficult to take out electron from here because now it is in a very stable state. That is why its second ionization enthalpy is very high. But here, if we talk about manganese, it is 4s2 3d5, right? Now, if you take out one electron, it will be 4s1 3d5. If you take out two electrons, after losing 2 electrons, it will become 4s0 3d5, and hence that is why manganese is stable in +2 oxidation state, because after gaining +2 oxidation state, it is becoming a very stable state. Okay, it is having D5 configuration, right? Okay, got it? Chalo. Now they are saying that the second ionization enthalpy of manganese is low as compared to iron. Now, if you talk about iron and manganese, iron is what? 26. It is 4s2 3d6. Manganese is 4s2 3d5. Right? Now see, when you are taking out electrons from this, the first electron you are taking out, the second electron you are taking out, right? Then it is easy for it to give first electron, then become this. After losing 2 electron, it will become 2 positive, it will become 2 positive here, right? But now manganese will not be able to give one more electron because it is in a stable state. But iron will be able to give one more electron because it is, after losing one electron, it will become 3d5. That is why it would want to lose the electron. So sometimes these things you have to see with the help of the electronic configuration. Just remember, half filled and fully filled are more stable. If some element is getting into a stable state, then it would easily lose that electron, and the ionization enthalpy is going to be very low for that particular element in that state, right? Now they are telling you the oxidation state that we have already done, right? Okay. Then there is oxidation state, very, very important. Basic, amphoteric and acidic oxides. This from here questions are also asked to you, right? So first is compound MnO, right? That is having ionic character. It is having +2 oxidation state. Easily you can calculate. And it is basic in nature. MnO2, it is amphoteric in nature. And Mn2O7, this is acidic in nature. That means, can you see that as the oxidation state is increasing, the acidic character is increasing, right? This is important conclusion from here, that as the oxidation state increases, acidic character increases. From here also, your JEE questions has been asked. Your JEE main question has been asked from this particular concept also, that as the oxidation state increases, the acidic character will increase, right? Okay. Now, these are the stability of higher oxidation state. Here they are telling you that why in halides the stability of higher oxidation state is more stable. Fluorides show greater ability to stabilize the higher oxidation state, right? This is due to high bond enthalpy, right? If you talk about the fluorides, fluorine is very electronegative, right? So whenever it will have the element in the higher oxidation state, for example, titanium in +4 oxidation state, right? And this is vanadium in +5 oxidation state, chromium in +6 oxidation state. These three fluorides are very stable. That means in case of fluorides, more oxidation state, more is the stability, right? More oxidation state, more is the stability. Got it? Chalo. Next we have again these oxidation state in oxides, right? As you can see that here, the oxidation state that are stable. Wait a minute. The ability of oxygen to stabilize higher oxidation state is demonstrated in the oxides. The highest oxidation number in the, this is very important, okay? The highest oxidation number in the oxides coincides with the group number and is attained as these oxides, okay? So it corresponds with the group number. What is the group number? And according to that, you will get the oxides. For example, if you talk about manganese, right, it is group number 7. That oxide is more stable, right? Here, when it is having existing in +6, it is existing in -2. This oxide it is becoming. Here, vanadium +5 oxidation state because group number 5. Here it is +4 oxidation state. Wait a minute. This is, yes, +4 oxidation state. This is -2 oxidation state. Here it is +3 oxidation state. It is -2 oxidation state, right? So basically till manganese, what is the group number? That oxidation state is more stable in case of oxides. And after that, beyond group 7, no higher oxides is formed, right? FeO4 is formed in alkaline media but decomposed to FeO3 and O2. That means Fe in 4 positive oxidation state is not stable. Higher oxides are not formed here, right? Higher oxides are not formed here. Lower oxides are formed here, right? Okay. Besides the oxides, oxocation stabilize, like for example, you have vanadium in +5 oxidation state. So this is the oxocation in which vanadium is in +5 oxidation state, right? Here also, if you see, here also your titanium is in +4 oxidation state, right? If you see X -2 is equals to +2, this is in +4 oxidation state, that is more stable. So this is what they are saying, that in higher oxidation state they will exist as oxides till manganese. After manganese, higher oxidation states will not exist, right? Okay. Now, stability of higher oxidation state, this is a very, very important question, right? That Mn2O7, this will exist, and here MnF4 will exist, right? Here MnO4 will exist. So that means in higher oxidation state, oxides are more stable. Ability to form multiple bond is the reason for oxygen providing better stability. Very, very important. Directly assertion reasoning question can be asked from here, that why oxides or they can ask you why D block elements, or they can ask you directly manganese. This is just an example they have given you, that higher oxidation state is more stable in oxides. This is directly your line of NCERT. Okay, so it's more stable in oxides rather fluorides. Reason is because here we are able to form the multiple bonds. Very, very important question. Okay, this is a very, very important assertion reasoning question. Okay, got it? Now, next is electrode potential. Now, from electrode potential, a simple concept you need to understand, that they will give you a couple. For example, the couple is M3 positive to M2 positive. Now, guys, first thing you need to understand is, here you will always observe that there is decrease in oxidation state. Decrease in oxidation state, that means there is a reduction, right? Whenever there is a reduction, that means you are checking the reduction potential. Okay, so now what you have to understand here, if this is more stable, this is stable, then it will be a positive potential. That means it is easily, if it can, this is unstable, this is more stable, so it is easily able to reduce itself. So reduction potential is positive, right? But if this is unstable, now do you want to become unstable in near future? Right? You also want to become stable, you want to become an engineer, get a job in Google, Microsoft, right? Amazon, right? So here also they want to become stable, not unstable. If we are saying that after clearing JEE, you will not become stable, would you want to clear JEE? No, right? So here, if we say that you, after losing or after gaining one electron, you will become unstable, they will not gain. So that is why reduction potential is going to be negative. Okay, so that was a simple, crisp concept that I told you. Simple concept. Okay, nothing hi-fi. This is a hi-fi language. Now I'll tell you the hi-fi language as well. Because in D and F block, the language of NCERT is like really interesting. Okay, so it's also for those students, because see, now in JEE means, so we don't have that much time to do DNF block in detail. But if you're very curious and you have done like a lot of things, other things, all the other things are done, right? You just find DNF block very difficult, then I would advise you one thing. On Vedantu NEET English, I have taken up DNF block, NCERT line by line, 3 lectures I have taken up. Go to that in detail. I promise you, not even a single question of JEE Advanced as well you will miss, right? Advanced I am saying, right? Because each and every single line of NCERT I have decoded there, right? Okay, but now here we are looking for the crisp conclusion of DNF block, right? So only nitric acid, very, very important line, only nitric acid and hot concentrated sulfuric acid react with copper, right? So if you talk about high, now this is important, high energy to transform copper to copper 2 positive is not balanced by hydration enthalpy. That means when you are transferring copper to copper 2 positive, it needs very high energy. That is why this couple, copper to copper 2 positive, will have negative electrode potential, right? That is why we are saying that only nitric acid and hot concentrated sulfuric acid, these are basically oxidizing agents, right? They will, what they will do, wait a minute, not oxidizing agent, yes, only nitric acid, that means to convert this into copper 2 positive, right? Okay, so what we need to do, oxidizing agent only, yes. So these two are the oxidizing agents. So to convert this into copper 2 positive, we need a very high hydration enthalpy that is not provided usually. But if we use nitric acid and hot concentrated sulfuric acid, then that energy we can provide. Okay, understood? Now, I'll just show you that table. Wait a minute, let me see standard electrode potential. So if you see here, so they are telling you the standard electrode potential, this is decreasing, this is the reduction potential, okay? This, so they are telling you the reduction potential. Very important thing. All the others have, I'm talking not about oxidation potential, reduction potential. There I was talking about oxidation potential. that oxidation potential of copper is negative, but reduction potential is opposite of oxidation potential. This will be minus, right? So very important thing, you will say this is minus, 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 plus. Reduction potential of copper is positive, right? All the other have negative reduction potential. Oxidation potential of copper is negative. That is opposite. That is minus 0.34. Right? Reason as we have seen this here. Reason, bacha, we have seen this here. Just now we have seen the reason. We have just now seen the reason here. What was the reason? Copper to positive. I am saying that here oxidation number is increasing. That means here we are talking about oxidation, right? We are talking about oxidation, right? If you talk about the opposite here, that means Cu2 positive to Cu. This is reduction. If we are saying the reduction is plus 0.34, that means from copper to positive, it is easily able to get converted to copper. But if this is positive, then oxidation potential will be negative. That means it does not want to get converted from copper to positive. That is a negative potential. That means it does not want to get converted from copper to positive. Reason is that it needs high hydration, high energy, which is not provided by the hydration enthalpy. This reason can be asked to you. This can be your assertion. This can be your reason. Right? This also can be asked to you, but only nitric acid at hot concentrated sulfuric acid are able to convert copper to positive. Is this thing clear to all of you or not? Right? Okay? Got it? Got it? Got it, guys? Right? This is very, very important point. Right? Chalo. Now, next is standard electrode potential. Right? Here though I have told you this before also, right? This is your copper, right? Copper is having the positive potential, right? Positive potential. From the table also you can see this, right? Here you can see the hydration energy, right? This is minus 2121. Yes, it is minus 2121. Very good. But the hydration energy is not sufficient to convert copper to positive. Right? Okay, the hydration energy is not sufficient to convert copper to positive. Right? Okay, chalo. Next is, this is done. Chalo. Next is your, wait a minute, here what they are telling you. Here though we are talking about the electronic configuration. That scandium 2 positive is this. After losing one electron, it will become scandium 3 positive easily. So its electrode potential will be positive only. Fe2 positive is this thing, right? If you want to convert it into Fe3 positive, it will lose one more electron and it will get converted to 3d5, right? Again, easily it will be converted, right? Now, for Mn2 positive, here you will have comparatively high value. Do you know what is the reason? What is the reason? Because here, when you take out the electron from a stable state, it is very difficult, right? That is why it will have high value. Now, zinc, it is existing in 3d10, right? You want to convert it into 3d3 positive. It's in a very stable state. It's fully filled configuration of d orbitals, right? That is why it will have the highest value, right? That is why it will have the highest value. Okay? Chalo. Now, next is magnetic property, right? So, just need to remember this formula. Not even this formula we will apply. We will just learn if you have one unpaired electron, 2, 3, 4, 5. For 1, you will have something 1.7, something 2.8, 3.8 or 9, something 4.9 and 5.9. Okay, so that will be your unpaired electrons and this is your magnetic moment. If you want to apply this formula, you can, but you don't need to apply because we've just answered this with the help of this simple trick, right? Okay. Now, let us talk about the colored compounds. So, colored compounds are due to DD transitions. right? Whenever you see that d orbital is empty, it will be colorless, right? So if you talk about the colored compound, unpaired electron it needs, no unpaired electron, then it can have charge transfer. For example, KMnO4. In KMnO4, you have manganese is in what oxidation state? X minus 8 is equals to minus 1. It is X is equals to 7. So manganese in plus 7 oxidation state. Can you tell me? Manganese is 4s2 3d5 plus 7 oxidation state. It will be 4s0 3d0. You will say, ma'am, KMnO4 potassium permanganate is purple in color. Why it is purple in color then? Here the reason is charge transfer. Here the reason is charge transfer. Even in K2Cr2O7, K2Cr2O7, here the oxidation state is plus 6. Right, as you can see here, this is 2x minus 14 is equals to minus 2. 2x is equals to 12. X is equals to plus 6. So, chromium in plus 6 oxidation state. Chromium is basically 4s1 3d5. Chromium in plus 6 oxidation state is 4s0 3d0. Again, it has no electrons. So, these are the two important compounds in your D block that are mentioned in your NCERT, which have 0 electrons in the D orbital, but they still show the color, not because of DD transition, but because of the charge transfer, right? Okay, except for these two, everything else in your syllabus will show color because of the DD transitions only, right? Okay, now as you can see here, you have titanium 3 positive has 1 electron, this has 2 electron, 10 electrons, so it will not show color. This scandium 3 positive, no electron, it will also not show color. Manganese 5 electron, it will show color. Fe3 positive, show color. Cu2 positive, show color. From the above table, it can be easily observed that scandium 3 positive has an empty d orbital. All other ion except scandium will be colored in aqueous solution because of DD transitions, right? Okay, got it? Now, next we have properties of D block, very important. First is formation of complex, like it is able to form coordination compounds, right, because of variable oxidation state, right, because it has the vacant d orbitals to accept the electrons, right, that is why it is able to form the complexes. Catalytic property, right, very important, very important. Vanadium 5 oxide is used in contact process, right, in the generation of SO3. Finally, divided iron, Haber's process. Nickel is a catalyst in hydrogenation. Then you have formation of intertransitional compounds, right? Intertransitional means with a non-metal, just like an alloy, they are forming a intertransitional compounds, right? Formation of alloy, brass. Now, copper and zinc are forming brass as the compound, a very useful metal, right? Then we have bronze, copper and tin, that is formed by copper and tin. Next is very important, your compounds KMnO4 and K2Cr2O7, right? Okay. Okay. KMnO4 and K2Cr2O7, here to directly the questions are asked, okay? Based on the reaction, direct questions are asked, so do not skip these reactions, okay? So whatever I am teaching you today, don't skip that, okay? Now, potassium permanganate KMnO4, as I already told you, this show color because of the charge transfer, right? Now, it is prepared from pyrolusite, right? That is MnO2, manganese oxide basically. Now, here it has X is equals to plus 4. Here it will exist in X is equals to plus 7. Now, let us see the preparation here, very important. So, all the points are not important for you. I'll just tell you the main important highlight of the reaction. First is from MnO2 ore, it will get converted to a green color compound, right? Okay, which will have K2MnO4, right? Here, after that, you will get purple color compound, that is your potassium permanganate. This is potassium manganate, right? Here the oxidation state is x minus 4, minus 8 is equals to minus 2, x is equals to plus 6, right? Here the oxidation state is plus 6. You can write it here. And here the oxidation state is plus 7. And here the oxidation state is plus 4, right? Okay. Whenever manganese is in plus 6 oxidation state, it is having again your question of JEE mean. That is why I am mentioning this, right? Very, very important question, right? This is in plus 6 oxidation state. This is in plus 7 oxidation state. It is showing purple color, and in plus 6 oxidation state it is showing green color, right? Next is preparation. Commercial preparation is not very important for you. You can also skip this, okay? Next is action of heat. This is also not very important for you, but these structures are important, right? If you have MnO4 negative, that is you have potassium, potassium permanganate. In this case, 2 you will have, this will be, wait a minute, हाँ, 1 oxygen ना, हाँ, ठीक है. So this is 1 oxygen is minus 1, others are double bondedly with the manganese. So this is a tetrahedral structure that it is forming. With MnO for 2 negative also it is forming a tetrahedral structure. These structures are basically tetrahedral structures. Okay. Now, very important thing, very important thing, that they are very good oxidizing agents. So they will behave very differently in acidic, basic and neutral medium. In acidic medium, important thing is they will give you both, they all are giving you oxygen, but this thing is important for you, that in acidic medium they are giving you Mn2 positive. I'll just write here Mn2 positive. What you need to remember is, in acidic medium it is giving us Mn2 positive. In basic and neutral medium it is giving us MnO2. Okay, these are two important points, that in basic and neutral medium it is giving you MnO2, in acidic medium it is giving you Mn2 positive, right? Okay, here Mn is in plus 4 oxidation state, right? Here it is in plus 2 oxidation. This is the first thing that you need to remember for potassium permanganate. If you don't want to remember the full reaction, okay with that. But just remember, in acidic plus 2, in basic and neutral it is MnO2, right? After this, how it is going to change how it is going to oxidize different compounds. So first thing is that they have asked you, right? That is, I know this is a full cramming chapter, right? So that's why I know you will waste your time in reading as well. That's why just go through these notes and revise it 3-4 times before the exam. Okay. Now I negative in the basic medium, right? Firstly, so I'll write this in the acidic medium. In acidic medium, I negative is converted to I2. Acidic medium, Mn is converted to Mn2 positive. Yes. Mn to Mn2 positive. Don't remember these reactions. Nobody is going to ask you full reaction here. Nobody is asking you to write down full balanced equation. Why to learn things which are not important? Learn what they ask you from here. They will ask you in acidic medium, I negative is converted to I2 and Mn is converted to potassium permanganate. Mn is converted to Mn7 positive is converted to Mn2 positive, right? Fe2 positive is converted to Fe3 positive. This was so simple. But C2O42 negative is converted to carbon dioxide, right? S2 negative is converted to simple sulfur. SO32 negative is converted to SO42 negative, right? NO2 negative is converted to NO32 negative. Okay, just remember these points here. Now you will find it difficult, but once you do this 3-4 times, it will become very easy for you, right? Okay. Is it hard to read? Wait a minute. Chalo, got it, guys? Okay. Now, after this, one very important point, in basic and neutral medium, I negative is converted to iodate ion. This question is frequently asked. In acidic medium, I negative is converted to I2. In basic medium, I negative is converted to IO3 2 negative. This is also your JEE means previous year question. Very, very important. Okay, very, very important. Right, rest of the things are the same only. Here S2O3 is converted to SO4, same. Here this to we have done, this to we have done. है ना? Other things are same only. Other things are same only. It will oxidize S2 negative to S only. SO3 2 negative to SO4 2 negative only. NO3, NO2 negative to NO3 negative only. But the difference is in iodine. The difference is here. This is the different point. Okay, iodine. I negative to I2 in acidic, I negative to IO3 negative in basic medium. Just remember, in acidic medium, someone is acid, he is not a good person, right? He will not have something, he will not donate that much, right? Donate, you can say, he will not have that much power to donate anything, right? But basic is a good person, okay? Basic is a good person, right? He has the power to convert it into something which it was not before, right? So this I negative did not had O before, but now it has converted because it is a basic medium. Basic medium is a good medium. That is why it has also provided oxygen. Oxygen means goodness. We are breathing oxygen. This is just a way to remember, okay? Oxygen means we are breathing it, right? So here we are providing oxygen because we are base, we are good people. That's why we are giving freedom here. We are providing oxygen, right? So in basic, it will provide oxygen, IO3 negative, right? Now from structures also the question can be asked, right? Basically first thing that they have asked in your JEE means, देखो बेटा simple question they are asking, right? From main points only, right? So if you want to like really get deep into this chapter, then you can just go through the NCERT line by line. But if you want to see the summary of this, that ma'am, at least I want to get marks from this chapter, then see this. First, what question they have asked is, they both are tetrahedral. On what kind of geometry they are in? They both are in the tetrahedral geometry, right? The geometry is tetrahedral, and this is the structure. Here you have in MnO4 2 negative, you have two bonds that are O negative, right? And in MnO4 1 negative, you have only one bond where there is single bond O negative. Rest of them are double bonds. Okay, this is existing in tetrahedral structures, right? Okay, chalo. Now they are saying manganese is paramagnetic and permanganate is diamagnet. Now they are saying manganate. So if you talk about manganate, this is your manganate. Manganate is Mn6 positive. Mn6 positive means Mn, what was the Mn? Mn was 3d5 4s2. You take out 6 electrons. 2 from here, 4 from here. 6 electrons I have taken out. I still have 1 electron, unpaired electron. That is why it is paramagnetic in nature. Very, very important. That's why it is paramagnetic. Manganese and permanganate. Manganate is, that's why paramagnetic. Permanganate, that is existing in Mn7 positive. Permanganate means KMnO4. You have to remember these two formulas. Permanganate and manganate, from where the questions are asked. First question can be asked based on the acidic and basic medium reaction. Mostly for iodine they will ask you, right? Then they can ask you the structure. Structure is tetrahedral. Third question they can ask you is for oxidation state of manganate and permanganate, or diamagnetic paramagnetic nature. If you remember the oxidation state, then so easily you can understand why it is para and diamagnetic. Mn7 positive means no electrons here. 0 unpaired electron means it is going to be diamagnetic, right? It is going to be diamagnetic. Now second compound to understand here is K2Cr2O7. In K2Cr2O7, guys, first thing is preparation, right? Here also remember the important colors here. Okay, so first thing is, from the chromite ore it is formed, it is converted to a yellow compound, right? This is your yellow compound, right? This is sodium chromate. Now orange compound of sodium dichromate is formed, right? Orange color of sodium, this is sodium chromate of yellow color, sodium dichromate of orange color, and then after replacing this with K, you will have orange color of potassium dichromate, right? Okay, the colors are important for you. The colors are very important, right? Next you have with alkali, how does it behave? So basically this is your orange color, right? If you give it alkali, it will get converted to yellow color. That means potassium chromate. That means this dichromate will be converted to, dichromate means Cr2O7 2 negative is converted to Cr2O7, Cr O4 2 negative in presence of alkali. This is important. Okay, this is important for you to remember that here. Okay, so it is converted from dichromate to chromate in alkali medium. Very, very important. You are preparing from chromate to dichromate. Then you can also convert dichromate back to chromate. They both will have the same oxidation state. This question has also been asked, right? If you calculate the oxidation state of this and this, what it will turn out to be? Here this will be 2x minus a minus 14 equals to minus 2. 2x is equals to 12. X is equals to plus 6. That means here the oxidation state is plus 6. What about this one? X minus 8 is equals to minus 2. Again, x is equals to plus 6. So directly the oxidation state of chromate and dichromate is plus 6. Okay? Got it? Got it, everyone? Hanji. Okay? Very good. Now, yes, we are talking about basically this chromate ion. It induces orange color, right? This induces orange color. Got it? Now, next is this also we have done, right? So, CrO4 and this are interconvertible in aqueous solution depending upon the pH value. That means if the pH, right? If you give alkali medium, that means you are increasing the pH. With more pH value, you will have chromate ion, right? With less pH value, that means in the acidic medium, you will have dichromate ion, right? You will have dichromate ion, right? Okay. Now the oxidizing power. Here the oxidizing power is not frequently asked, but yes, you can remember this. That here, firstly, in the oxidizing character, this dichromate is converted to Cr3 positive. That is the first thing. Here there is no such rule of acidic, basic, neutral, medium. Simply it is converted to Cr3 positive. In potassium permanganate, we have Mn2 positive, MnO2 in basic, neutral, medium. Here there is no such thing. Simply it is reduced. It has been reduced to Cr3 positive, and it will oxidize the other elements, like it will convert SO4 2 negative to this one, right? That is your ferric sulfate. No, wait a minute. This is converting ferrous to ferric. That means Fe2 positive to Fe3 positive. Just remember this thing. Here it is converting S2 negative to S, right? You can remember just this thing. Here it is converting Cl to Cl. Wait a minute. This is Cl negative only. So, hydrogen chloride to chromium chloride. Not to chromium chloride. This is converting Cl negative to Cl2. That means here the oxidation state is increasing, right? Okay. Wait a minute. This is -1. This is 0. Here the reduction is happening. This is x minus 3 is equals to 0, right? Chromium is in +3 oxidation state. It will be +3 plus 3x is equals to 0. 3x is equals to -3. X is -1 only. है ना? So here it is -1. This is -1 oxidation state. Here also it is -1 only. Here also it is -1. Here only it is having 0. So -1 to 0, that means oxidation number here is increasing. Okay, okay, yes. It is going from Cl negative to Cl2 only, right? Okay, Cl negative to Cl2 only because it is oxidizing, na? So it will increase the oxidation number. Yes. So don't mark the box here. It is going from Cl negative to Cl2. This also you have to see where it is getting converted to. It should have oxidation, na? Then only we can say something is happening. Cl is getting Cl negative to Cl negative is no oxidation. Cl negative to Cl2 is the oxidation. Okay? Got it? This is how you will identify. Right? Okay? Chalo. Now you have, again, this is simple. I think that is the same thing. Right? So, here I negative. Now, there is no rule of I negative in basic acidic medium. Always I negative to I2. So, just remember this thing. I negative to I2. Okay? You don't need to remember the full equations. Okay? That's why whatever I'm writing in this yellow pen, that you have to remember. Okay? You don't have to remember this full. Just Fe2 positive to this. S2 negative to S. Cl negative to Cl2. If you don't want to remember this, you can skip this also. Because you know that oxidation will happen. Right? So, you know that Fe2 positive will get oxidized to Fe3 positive only. Right? Okay? Now, this again, this is getting converted to, here this is SN2 positive and here this is SN4 positive. So, it is getting converted to stannous to stannic. Right? So, basically, this tin is increasing the oxidation state here as well. Okay? Got it? Now, these are the shapes, the structures. Very important, that chromate ion, right, that is existing in tetrahedral shape, but dichromate ion is existing in two tetrahedron sharing one corner. So this is two chromium ion. They have one oxygen atom, that is a bridge in between them, and you have three oxygen atoms here, right? Okay, got it? Got it, guys? So this is your chromate and this is your dichromate ion, right? Okay, guys, any problem? Now after this we are also going to start the previous year questions. Okay, chalo. Now lanthanoid. Here few things you need to remember here. First is lanthanum to lutetium, right? 57 to 71. This lanthanum actually belongs to your D block only, right? But still we study this in lanthanoids as well. But actually all the lanthanoids and actinoids are the group 3, are belonging to group 3, right? Okay, they all belong to group 3 only. It's just that from group 3 only, this is lanthanum, this is actinium, and from here we have the starting of lanthanoid and actinoids. So all the lanthanoids and actinoids belongs to group 3 only, right? Next is the general electronic configuration, the exception. This exception is very, very important, right? General electronic configuration is, you have xenon 4f1 to 14, 5d016x2. Right, so that is the general electronic configuration. But when you talk about the gadolinium, right, in this case what you will have, here you will have 5d1, there are 2 electrons in 6s and there is only 1 electron in 5d. Okay, so this is 4f7, 5d1, 6s2, and this question is very, very important. And some of the other electronic configuration are also directly asked. In lanthanoids and actinoids, so they will rarely ask you, but in lanthanoids, mainly their focus is on the exceptional electronic configuration. They can ask you that, right? Now, here you have this thing, gadolinium, you have seen. Now, first I'll just teach you directly the table here. This is the table, okay? This is the table. Now, from here, let's see the electronic configuration from this table only. So these are the lanthanoids. So as you can see, where is gadolinium? Gadolinium is this, right? As you can see here, we have First thing is, here we have 5d1 6s2, then you have 4f1 5d1 6s2. Okay, now after this is 5d1 6s2. After this you are adding the electrons in 4f1, then you have 4f3 directly. So basically what we are doing here we have 4f1 4f3 4f4 5 6, then 7, again you have 7, 8 we don't have, 9 10 11 12 13, and this is also, ytterbium is also exceptional. Okay, so I'll just highlight the points that are your exceptional. Firstly, this neodymium has been asked in your JEE mains, so you can write it here. This is important, right? Then cerium is important. Cerium is 4f1 5d1 6s2. Then neodymium is important, right? Then you have gadolinium is very, very important, right? Then so it's simple. Then ytterbium is important. So these are the important electronic configuration that you must remember. Okay, these are the important electronic configuration that you must remember. Mark this in your NCERT. Very, very important, right? This is your previous year question, and this is also your previous year question. This is also similar to this, that is why I have marked this. And cerium is also very important. But if you ask me, ma'am, do I also need to remember europium? Yes, also remember europium. I'll tell you the reason behind that. Because europium is also existing in half filled. That is why I'm asking you to remember europium also. Okay, got it? Chalo. Now, this is so after losing 2 electron, it will lose electron from this 6s2. Right, after losing 3 electrons it will become 4f1, right? Okay, so this is what we have here, right? Okay, after losing 2 electrons, after losing 2 electrons, after losing 2 electrons, so that is too simple. Just remember these things, just remember these things. Now one more thing that you can remember is, usually the most stable electronic configuration of lanthanoids is +3, but EU, if you talk about europium is very stable. Europium is having stable electronic configuration, that is 4f7 in 2 positive state. That is why EU 2 positive, europium 2 positive will exist. Similarly, if you talk about cerium, in cerium you have this thing. In +4 oxidation state, it will exist as 4f0. That is a very stable configuration. That is why this question has been asked, that europium is in +2 oxidation state, cerium in +4 oxidation state, both are stable. But one of them is oxidizing agent, one is reducing agent. We know that both are more stable in +3 oxidation state. Can you tell me why? Because +3 oxidation state is the group oxidation state. So whenever you are in a family, you have to obey the family as well, the rules of the family. So the rule of the family is +3 oxidation state. So here you can see the oxidation number is increasing. It is getting oxidized. Here oxidation number is decreasing. It is getting reduced. Right? Because it itself is getting reduced. That is why it is a very good oxidizing agent. It itself is getting oxidized. That is why it is a very good reducing agent. And this question also can be asked to you. Very, very important question this is. Okay. Very, very important question. Okay. Yes. Okay. Got it. Now, I think that's it. These are the questions that you don't have to remember all the electronic configuration here. There are few questions that they can ask you that I have already told you, right? Okay. Chal. Now, next is the chemical reaction of lanthanoids. What kind of chemical reaction they can ask you? Basically, always lanthanoid will exist in Ln3 positive. So, if you have oxygen, then it will form cross multiplication. It will form this kind of oxide. With the lanthanoid and halogen, this is 3 positive, it will form cross multiplication. It will form this kind of halide. So just cross multiply with the opposite ion and you will get your answer. Right? With acids, it is going to give you hydrogen. With halogen, LnX3. With water, it is going to give, water means it will be Ln3 positive and OH negative. Cross multiplication, you will have this thing. Right? With carbon, it is going to give you LnC2, right? LnC2. Here, carbon will have negative charge also, negative oxidation state, right? This is your Ln3 positive and N2 negative, right? That is why this is existing as Ln. Now here it is having Ln3 positive and S2 negative, that is why it is Ln2S3. Here it is Ln3 positive and O2 negative, that is why it is Ln3O2. Got it? Yes, bacho. So this is how you will remember this full chart, right? Hanji. Chalo, let us see if anything is left here. We have the atomic sizes. They will not ask you the trend here. Very abnormal trend it is following, right? So definitely they can ask you the lanthanoid contraction. The application of lanthanoid contraction, we have seen that in 3D, the size of 4D and 5D series will become similar. That is the application of lanthanoid contraction, right? Next is oxides. So basically this these 5 compounds, they will exist in +3. Mostly the group oxidation state is +3 only. +3 is the most stable oxidation state. But yeah, some of them can exist in other oxidation state depending upon the stability. But I would advise you not to, if you don't want to remember this, you can just remember about europium and cerium, right? Okay, but if you want to remember this with the help of some mnemonic, you can remember these compounds as well. This is based on the stability. Fully filled, half stable configuration. Based on that, they have given you the configuration, oxidation states here, right? Okay. Chalo. Next is actinoids. So if you talk about the actinoids, they are starting actinium, that is in group number 3. After actinium till lawrencium 103, you will have the actinoids. They are basically very radioactive. That is why it is very difficult to study them. And that is the reason questions are not asked from this side, right? They can ask you 1-2 exception here, like you have curium, right? So in curium, this is the electronic configuration, right? Okay, 5F7, 6D1, 7S2, right? This is the exception that they can ask you, right? Now, you don't have to study this full table here, right? Okay, you can go through this once, but very rarely they will ask you this. Mostly they will ask you lanthanoid electronic configuration, not from actinoids, but some of the actinoids, like I have written here, curium, they can ask you this, right? Okay, now actinoid contraction, due to the poor shielding effect of 5F electron, actinoid contraction is more as compared to lanthanoid, because 5F shielding is even stronger as even poor as compared to 4F shielding, right? Okay, now actinoids also have variable oxidation state. You don't have to remember all the oxidation states here. Just go through this, that it is very variable. Reason you need to remember, due to very less energy gap between, this reason is very important. Reason is important. Reason is important. They can ask you why actinoids has variable oxidation state. Reason is due to very less energy gap between 5F, 6D and 7S. Right? I think you are not able to see this. So wait a minute, let me write it myself. Due to very less energy gap between 5F, 6D and 7S. Because of this thing, due to very less energy gap, they are not able to, because of this less energy gap, electrons are jumping from one point to other. That is why variable oxidation state to a very high extent, right? Okay. Chalo. Now let us see. Now let us just go through this electronic configuration once, right? In a very short manner, I have just written the notes here. You can go through them once, right? So basically, first is the electronic configuration, right? As I have written here as well. This so I always tell my students, right? That cerium, gadolinium, ytterbium and europium. These 4 electronic configurations are important for you, right? These 4 electronic configuration, I have ticked that in the table also, that remember these 4 electronic configuration, they are very important, right? Okay, then this is the general, these are the exceptions, right? Then you have first transition series, that is 3D. Here, this though we have done, na? Scandium to zinc. Then you have ytterbium to this, wait a minute. Wait a minute. Wait a minute. Wait a minute. Chalo. Okay, where it was. Okay, we were here, right? This though, guys, we have already done the previous, the first slide also, right? Now the difference of actinoids and lanthanoids includes elements with atomic number beginning from 57 ending with 71, include elements with atomic number beginning from 89 to 103. The range is important for you, right? Then they are not radioactive, right? Lanthanoids are non-radioactive except for promethium, right? Now here you have all actinoids are radioactive in nature, involve 4F, involve 5F. Their paramagnetic property of lanthanoid can be easily explained, and these are very difficult to explain. That's why we are not studying them. They do not have tendency to form oxocation. Oxocations also exist here. The compounds formed by lanthanoids are less basic, and the compounds formed are very highly basic in nature. Okay, got it? This is the P block. Before P block, we will do the questions of D block. Okay, so let's start with the questions. Now, questions also you will find new questions here. So whatever I'm teaching you today, just go through that, right? Okay. Okay. Chalo. Now, here the first question on your screen is based on the magnetic moment. Okay. The magnetic moment of a transition metal compound has been calculated to be 3.87. Right? 3.87 means, firstly, just remember that 3 point means they are talking about unpaired electron is 3. You just need to calculate where you have 3 unpaired electrons here. Right? You just need to find out where you have 3 unpaired electrons here. So for that, chromium is 24, right? Chromium is 24, manganese is 25, vanadium is T23, this is 22. Right, here it will be argon, this will be 4s2, 3d4, 4s1, 3d5, right? Wait a minute. This will be 4s2, 3d5. This will be 4s1, 3d5. Exception, na? Chromium is exception. This will be 4s2, 3d3. This is 4s2, 3d2. After losing two electrons, it will become, this is 2 electrons, it will become 4s0, 3d4. It will become 4s0, 3d5. It will become 4s0, 3d3. It will become 4s0, 3d2. So 3 unpaired electrons are present in vanadium 2 positive. So answer is going to be C is the correct answer. Okay, very simple question. Now, next is the ammonical metal salt solution. Now they are saying that the ammonical metal salt solution give brilliant red precipitate on addition of dimethyl glyoxine. So these are the questions that I was talking about, that you will see new questions here. Just go through those questions once, right? Because these are picked out from your previous year. They can be directly repeated, right? So ammonical metal salt give brilliant red precipitate. So you have to remember that ammonical metal, it will give red precipitate on addition of dimethyl, DMG. DMG with which thing? With nickel. With nickel, it is forming a compound which is red in color, right? So answer is going to be D, nickel. Answer is going to be D, nickel. With nickel, it is forming a compound which is red in color, which is red in color. Right? DMG is basically, it is bidentate ligand. It is bidentate ligand. That is why we use this to find, because it can, if it is having two positive, all are having two positive. So this bidentate ligand is going to, this with this metal, it is going to form a chelate here, right? It is going to form a chelate. Because of the stability of this chelate, it is going to give a specific color. And with nickel, that specific color is red. With nickel, that specific color is red. Okay? Chalo. Next question is K2Cr2O7 paper acidified with H2SO4 turns green when exposed to. Now this is from your reaction only that we have studied for K2Cr2O7. K2Cr2O7, potassium dichromate, acidified with dilute H2SO4 turns green. That means it will turn to be chromate, right? On reaction with what kind of thing? Dilute H2SO4 and what? Dilute H2SO4 and carbon dioxide, sulfuric dioxide, then you have hydrogen sulfide and sulfur dioxide. Acidic condition it needs. Acidic condition it needs. Okay. In dilute H2SO4, when you will add SO2 also, then it will give you green color, right? Okay, so just let me show you the reaction here, right? It will get converted to Cr3 positive here, right? Cr3 positive. And here it will convert this SO2 to SO42 negative, right? Okay, so this is the reaction. In the acidic medium, this reaction is going to happen. Now, what thing is important for you to remember? That K2Cr2O7, or just remember Cr2O7, 2 negative, is getting converted to 3 positive. This I have told you, right? Now, you need to identify something which can easily get oxidized here. So, out of these 4 options, SO2 was getting easily oxidized, right? Okay, so answer is SO2. Okay, answer is SO2. Chromium in +3 oxidation state is orange. In +3 oxidation state, it is green in color. Okay, chalo. Now, next we have match the following list. This is the list that they have given you. The list is based on the application of D block metals, right? The application, let us see. Firstly, तो they are talking about syngas, है ना? Cobalt catalyst, syngas, nickel catalyst, brine solution. Okay, so these 3-4 things they are talking about. It's not hybridization. It's not hybridization. This is where it is used, right? So I think brine solution is used in H2Cl2 production. D is 1, right? This we have done. Then cobalt catalyst is used in A4, methanol production, A4. This though guys, these are applications, okay? This though you have to remember them, right? Syngas is used in coal gasification. Nickel catalyst is used in water gas production. So I think the answer should be D. Okay, answer should be D. Okay, just eliminate the options here, you will get the answer. Answer is D is the correct answer. Okay, so you just have to remember that which is used where. Exact direct question can be asked to you as it is copy paste. So these are your theoretical questions which don't have as such any concept, right? This is theoretical question. As it is, they can ask you this. So instead of right now is the time, if you have time, you can go through the full NCERT also, that will benefit you. But if you don't have the time, at least do the previous year questions, okay? Because you never know, same question will be repeated and then you will say, yes, thank God I watched that lecture, and now I am safe, right? So potassium dichromate act as strong oxidizing agent in acidic medium. During this process, the oxidation state change. This is conceptual question, okay? This is not a theory cramming question. This was a theory cramming question. This is not a theory cramming question. From here, any student can get easily number, right? You can easily get your number here, right? Okay. Now, most welcome, Fiza, most welcome. Now, we know that in strong oxidizing agent in acidic medium, it was getting converted to Mn2 positive, right? So it was getting converted from Mn, wait a minute, potassium dichromate, acha, I thought KMnO4. Acha. Potassium dichromate is converted from Cr2O72 negative to Cr3 positive. That means here X is equals to plus 6, right? That means plus 6 to plus 3 it is getting converted. So answer will be B. Okay, answer is going to be B is the correct answer. Answer is going to be B. Okay? Okay. Okay, Farhan. Now, next question is the set of, now they are saying the set of correct statements is manganese exhibit plus 7 oxidation state in its oxide. Okay. In its oxide, Mn2O7. Mn2, wait a minute, manganese is Mn2O7. In this oxide, it is getting 2x minus 14 is equals to 0, 2x is equals to x is equals to plus 7. So yes, it is having plus 7 oxidation state, it is true. Ruthenium and osmium exhibit plus 7 oxidation state. So they are existing as, wait a minute, plus 8 oxidation state. Na? They are existing as osmium OSO4. Now this is also having plus 8 and plus 8 oxidation state. This is also true, right? Then scandium shows plus 4 oxidation state, which is oxidizing in nature. Scandium, so we have seen that scandium was showing only plus 3 oxidation state. So this is not true. Chromium shows oxidizing nature in plus 6 oxidation state. We know that chromium, when it is in K2Cr2O7, it is existing as chromium 6 positive only. That means it is showing oxidizing nature. So this is also true. So 1, 2 and 4 are true. 1, 2 and 4 means B statement is, B is the correct answer. Okay. B is the correct answer, right? Okay. Very good. Very good. Most welcome, Farhan. Most welcome. Okay. Now, next is a solution of CrO5 in amyl alcohol has a dash color. Again, a color-based theoretical question. Okay. So, basically, CrO5, that means chromium is existing in plus 5 oxidation state, right? Basically, this amyl chloride is pentanol, right? So, it is having blue color. Let me tell you firstly that it is having blue color. Okay, it is going to give you blue color. Okay, it is going to give you blue color, right? Okay, again, theoretical question it is, right? Okay, got it? Very good. Yes. Hanji. Now, next we have, yes, Shri, yes, you are right. Ruthenium and osmium, plus 8 oxidation state. Yeah. Now, then we have to inhibit the growth of tumors. Now, this is a simple question. Okay. This is, I would say, this is a simple question. You can easily answer this. Now, to inhibit the growth of tumors, identify the compounds used in the following. EDTA? No. Coordination compound of platinum, right? And that is not penicillin, that is cisplatin. So answer is B and D is the correct answer. Cisplatin, which is a coordination compound of platinum, that is used as an inhibitor in cancer tumors. Right? So answer is A is the correct answer. Guys, see, if you do hard work in inorganic chemistry, it will just take you 1 second to solve the question. You will get to know, you will not have negative marking. The best part about inorganic chemistry is that you will not have negative marking here. Either you will know the answer and you will mark it tick, or you will just see that I don't know this answer, you will skip that. In organic, when you talk about organic chemistry and physical chemistry, the problem is that we have to solve this, we have to invest our time, then we will know whether we are able to solve it or not. Right? So here, so you will just read it and you will know that yes, I know this or not. That's the best part. Now, I think you will be easily able to answer this, right? KMNO4 oxidized, I negative in acidic and neutral. You will see most of the questions, so you can answer. There are some questions related to color, which are not even in your NCERT, right? They are different questions, right? So for those questions, don't skip inorganic. So students usually see these kind of questions, okay? They see these kind of questions. They will like, inorganic chemistry is very difficult. Let's skip this. Array, this is only one kind of question, okay? You can also get these kind of simple questions. This is also simple question. This is also a simple concept-based question, okay? So, very good. In acidic medium, it is I negative is getting converted to I2. In basic medium, it is getting converted to IO3 negative. That means A is the correct answer, right? Here it is getting converted to I2, and in basic medium, it is getting converted to IO3 negative. So A will be the correct answer here. Next, you have ND2. This also I told you, right? This is from F block lanthanoids. Now, here the electronic configuration is xenon 4F4 6S2. After losing 2 electrons, it will become xenon 4F4. So answer is 4F4, that is B is the correct answer. Okay, B will be the correct answer that I have told you. Important electronic configuration to remember, because this is what JEE means, previous year question. Okay, now that's why I have also pointed out other important electronic configuration that they can ask, because they can ask you question directly from lanthanoid. Some of the good exceptions or good, basically they will ask from lanthanoids only. That is my idea, right? Now the correct order of basic nature of oxides of vanadium is, correct order. This though we have seen that as the oxidation state increases, acidic nature increases. So basic nature will decrease. That means maximum oxidation state, here it is existing in +5. It is having maximum acidic character, minimum basic character. Then this is existing in +4, this is +3. है ना? I think the answer should be A. Yes. Okay. Answer is A only. So as the oxidation state is increasing, here oxidation state, so in acidic state it is vanadium 5 positive, then you have 4 positive, then you have 3 positive. If they ask you the acidity, this also I told you that from this concept also they can ask you the question. Okay. Any oxide they can give you and they can ask you the question. Okay. So answer is A. Answer is A is the correct answer. Got it? Chalo. Next we have, given below are two statements. So they have given you two statements here. One is labeled as assertion and other is labeled as reason. The first ionization enthalpy, again a simple question, right? The first ionization enthalpy of 3D elements is more than that of group 2 elements. This is an important question, okay? So basically, if you see the enthalpies here, this is 336, okay? Not 356, this is 636. Magnesium, that is your group 2 element, that has an enthalpy of 656, right? And from scandium till manganese, not even manganese, till chromium you can say. From scandium till chromium, the energies are less than your magnesium, right? After that it will increase, but till chromium it is same, right? So you can say that first ionization enthalpy of 3D elements are more. No, this is false. first ionization enthalpy are less as compared to group 2 elements. This is false, right? Okay. Now, next is you have 3D series of elements. Successive filling of d orbital takes place. That means when you are successively filling, right? Three elements, successive filling of d orbital take place. Whenever you are filling the d orbital, d1, d2, d3, d4, d5, d6, successive filling is taking place now. So this is the correct option. So answer is A, if A is false and R is true. Got it? How I answered this? How I answered this thing? They are saying that the first ionization enthalpy of 3D, this is a data based question. You have to know the data here. 3D series, 3D series, 3D series have till chromium, the ionization enthalpy is less as compared to magnesium, but after that it will increase. So we can't say that always it is more. No, till chromium it is less. So here it is a false statement. So that's why C is the correct answer. Got it? Okay, now one student is asking, ma'am, please repeat this thing. Guys, very simple. See, very simple. This is the electronic configuration, right? After losing 2 electrons from this side, it will have N4F4, and they are asking you the electronic configuration of Nd2 positive, that is 4F4. So answer will be this. B is the correct answer, right? Okay. Okay. Ma'am, B option repeat means? Chalo. Now, next we have two statements. See, in inorganic chemistry, though, it's a trend that they will ask you assertion reasoning, right? Okay. Now, the first ionization, this is the we have done. Okay. Next is, which of the following elements have half-filled f orbital in their ground state, right? So here also you can see that they are asking you from the lanthanoids. That's why I told you that see the lanthanoids. From lanthanoids they can ask you the electronic configuration. Two to we have seen only. I think this is the third question from electronic configuration of lanthanoids, right? So mostly the hint is that from lanthanoids electronic configuration they will ask you the questions. Okay, so these are the 5 elements that they have given us. They have also given us the atomic number here, and they are asking that which will have half filled f orbital. So if you see the electronic configurations here, right, this is from the table that we have picked out, right? This will have 4f6 6s2, 4f7 5d 6s2, 4f7 6s2, and this I have told you, if you remember, when we were doing this, I have told you here only that remember for europium and gadolinium, it is 4f7. Why I asked you to remember? Because mainly they wanted to ask that, do you know that which element has half-filled configuration? This is what they wanted to ask. A student who have gone through this in detail, for him or her, it's not very difficult question. They to know that europium and gadolinium has half-filled configuration. Directly they will answer it europium and gadolinium, right? Okay, that is why whatever I am asking you to learn, that is important. Okay, so focus on that thing. Now, here what you will have, yes, europium and gadolinium, that is B and D. So answer is A is the correct answer, that is B and D will have half-filled configuration, right? Okay, yes, ready, that is not in your syllabus. Okay, that is not in your syllabus. Don't do something which is not in your syllabus, right? Okay, chalo. Now, I don't want to confuse you with unnecessarily stuff, right? Now, next is highest oxidation state of manganese exhibited in Mn2O7, right? Here it is having, okay, the correct statement about Mn2O7. Mn2O7 is tetrahedrally surrounded by oxygen atoms. Have we seen the structure here? Mn2O7 was this structure, right? This structure it was. It was tetrahedrally surrounded by these elements, है ना? Tetrahedrally surrounded by these elements, right? So it is tetrahedrally surrounded by oxygen atom. That is true. Mn is octahedrally surrounded. That is false. Contains Mn no bond. Yes, that contains Mn. No. So it is having Mn is tetrahedral. Yes. If you see this particular site, it is tetrahedral, right? It is also tetrahedral, right? So answer is A and C are the correct answer. So answer is A. Okay? Answer is A. Okay? Okay? So, beta, I am not a Don or a Bhai, okay? Who is leaking the paper here, ma'am. All the question, guys, learn this and all the question will be in your JEE. I can only predict. I can only tell you that previous year questions are important. Same kind of questions will be there. Right? Firstly, let us complete D block, okay? After that, I'll give you the break. Let me complete how many questions more? Let me see. Number of electrons, reduction of manganate. Chalo, 3-4 more questions we are left with D block, okay? Let us do those. Now, manganese is tetrahedrally, this so we have seen. Next is, given below are the two statements. The statements are, copper 2 positive in water is more stable than this. So basically, copper positive dissociates into copper 2 positive and copper 0, right? This not dissociate, it disproportionates, right? It disproportionates into copper 2 positive and copper, right? That is why copper 2 positive in water is more stable. That is so true. This thing is so true that copper 2 positive disproportionates into copper 2 positive. That is why copper 2 positive is more stable, right? Enthalpy, now why? This so I have told you why copper 2 positive is more stable. Reason is, enthalpy of hydration for copper 2 positive is much less than copper positive, right? Enthalpy of hydration is for copper 2 positive is less than that of copper positive. That is the reason why copper 2 positive is more stable. So this is true also and this is the explanation also. So both A and R are correct and R is the correct explanation of A. Right? So answer will be A is the correct answer. Right? Okay. Chalo. Next we have how many. Now they are saying again based on your I think electronic configuration only. How many following metal ions have similar value of spin only magnetic moment? A very, very simple question. Right? This is a very, very simple question this is, right? So this you have to tell how many of them are having spin only magnetic moment equal to have similar spin only magnetic moment, right? So just electronic configuration you need to see, right? So here as you can see, vanadium 3 positive is having 3d2, this is having 3d3, 3d6 and this is having 3d7. Right, this is the electronic configuration, right? Now it is having 2 unpaired electron. How do you calculate the unpaired electron? This is the D, this is D. I am just drawing the D orbitals here, D orbitals here, D orbitals here, right? Here what you will see, 2 electrons I am adding, 3 electrons I am adding, 4 electrons I am adding, 3 electrons I am adding, right? So what you can see, these two are having the same unpaired electron. Wait a minute. Acha, why they have 3? Acha, ye to I forgot to tell you. This have 3d7, so answer will be 1, 2, 3, 4, 5, 6 and this is 7. Wait a minute, let me just erase this here. It will be, wait a minute, it will be 1, 2, 3, 4, 5, 6, 7. So there are 3 unpaired electrons here, 3 unpaired electrons here. So answer is both of them 2. That means chromium 3 positive and nickel 3 positive. This and this, they are going to have the similar spin magnetic moment, right? Okay, because that is 3.8, right? Okay. Now, and question is the number of electrons, they are saying the number of electrons involved in the reduction of permanganate to manganese dioxide in acidic medium. The number of electrons involved in reduction of permanganate to manganese dioxide. Firstly, though, guys, you need to remember that KMnO4, that means MnO4 negative, to manganese dioxide, that is manganese dioxide, the number of electrons involved. So you just have to see the electronic configuration here, okay? So this is, the oxidation state. This is x minus 8 is equals to minus 2, x is equals to plus 7. This is x minus 4 is equals to 0, x is equals to plus 4. So how many electrons are involved? 3 electrons. Right, 3 electrons are involved here. So answer is 3 electrons. Again, a simple question, okay? I won't consider this a tough question. This is a simple question, okay? A simple question, right? Next we have 2-3 more questions we have from D block. After that, after the break, we are going to start with P block. With P block, though, very simply, I have just a very important points I have taken out from the P block that are very, very important for you, right? So, match list 1 with list 2. List 1 is carbon tetrachloride. That is a very good fire extinguisher, right? So, A3. Again, this is a theoretical question, okay? Methylene chloride. That is a good paint remover, I feel. Yes, that is a paint remover, hai na? DDT, that is the all of you know that DDT is used in insecticide. C4, hai na? We are getting this only option the right. Freons, CFCs, these are refrigerants. So D is second. So answer is 2 is the correct answer. Okay, second is the correct answer. I think this question is not from, you can't say this question is from, I think by mistake we have put this question here, right? But this question, I would say this is from haloalkanes, halorines, right? So yes, from the application of haloalkanes and halorines. Acha. After this P block, after this we have questions for P block. D block questions, guys, we have done. Okay, D block question, guys, we have done. DNF block, you have seen that whatever I am teaching you, same kind of questions they are asking. Yes, some theoretical questions are there. For that, just go through the previous year questions if you don't have that much time. Okay, yes. Now after this, in P block, though, they don't ask questions from color. Very rarely they will ask questions. In P block, the focus is more on the structures and more on the exceptions, right? Because in P block, you have a lot of exceptions, right? Okay, yes. Now, after P block, we are going to, after this, we are going to start with the P block, right? All the tables, all the exceptions we will do, right? After that, we are going to also look for the P block previous year questions, okay? Yes. If you do D block NCRT, na, that is more than enough. D block NCRT, if you do properly, then to you will be amazed to know that that's such an interesting chapter, right? Usually block chemistry is usually we are like, okay, we hate block chemistry, ma'am, so much cramming, like, ma'am, it's literally, many students are really, they are very non-interested in inorganic chemistry, and I understand where you have so much cramming. But when you go through, especially D block, when you go through the concepts of, because in D block there is more concepts involved. So when you go through those concepts, then you will find it very interesting, right? Yes. Chalo. Now, I'll give you break. Right? Break for how much time? 20 minutes. Because guys, even I need to have dinner, right? So now we have 9 p.m. So I'll see you at 9:30, okay? The class will resume at, wait a minute, just me write it here. The class will resume at 9:30 p.m. Okay? Okay? Yes, bachcho? Chalo. So I'll all see you at 9:30 p.m. after the dinner. Okay, so you also have your dinner, and after that we are going to finish P block as well today itself. Okay, and see you all after the break. And I am waiting for you to like this session. Till then, share this session with your friends. Okay, so right now, just share this session on your WhatsApp group, on your Instagram. You can also tag me on Diksha __ Kaushal. Right, share this session so that more students can join and get benefit out of it. Okay, then see you all after the break. Okay, yes, everybody, am I visible? Everyone, am I visible? Yeah, thank you so much, Lord. Yes. Yeah, that is a very useful session, NCRT line by line D block. It's a very, very useful session. So let me firstly just text the students that I'm live. Chal. Shall we start the class? Yes, everybody. So, starting with the exceptional trends of P block, right? So, first is let us start with the exceptional trends of P block. As you can see here, group number 13. So, firstly, we are going to see the group number 13 exceptional trends, right? For that, you also need to know one more thing here, that is the tables here. Okay, so this is your group number 13 table directly from your NCRT, right? From this table only I have picked up the trends and that are frequently asked in your exam. Okay, so I'm just giving you the trends here, right, directly from the tables, right? So the first is for first we have for group number 13. So if you talk about group number 13, what you will see, the oxidation state. So always remember throughout P block what we will study, in fact throughout this periodic table, because in P block we don't study the series. In D block we were studying 3D series, right? We were going along the period. But in P block, we will study the groups, group number 13, 14, 15, 16, 17. That's how we are going to study the P block, right? So first thing that you need to remember about oxidation state is that lower oxidation state and higher oxidation state, there is a concept of lower and higher oxidation state that will differ according to the group. Now that will depend on the outermost electronic configuration. Now we know that here the outermost electronic configuration, general electronic configuration is Ns2Np1. Because of that, when all the electrons it will lose from S as well as from P as well, that is called the higher oxidation state. Here the higher oxidation state is +3, right? And lower oxidation state is when it is going to lose the electron just from the p orbital. Here in p orbital you have one electron, that is why the lower oxidation state is +1, right? So always you don't have to cram any oxidation state here. Lower and higher oxidation state you can just see from the group number. Now second thing is lower oxidation state, its stability will increase down the group. That means if you talk about group number 13, this is group number 13. Now, if it is existing in lower oxidation state, then thallium will be the most stable. Tl positive is the having the maximum stability, because lower oxidation state increases down the group and higher oxidation state decreases down the group. That is why boron 3 positive is having the maximum stability for 3 positive state, right? Okay, and here also one more point about boron is that boron will form covalent compound. Because of its small size, it will form covalent compound. Rest of them can form ionic compound as well, but this will form covalent compound, right? Now this was about the stability of oxidation state. Next is Lewis acid character. If you talk about the Lewis acid character, that is going to decrease down the group. This is for the halogens, right? With the halides, if you talk about the halogen, if you talk about the halides of the boron family, the Lewis acid character is going to decrease. Can you tell me the reason behind that? Because down the group we know that electron negativity will decrease, right? What is a Lewis acid? A Lewis acid is basically electron deficient, right? So here what you will have, because boron, right, it is not having that much electron, because see boron, what will happen now with aluminium, so it will exist in, for example, AlCl3, it will exist as a dimer. Boron, you will never see boron as a dimer. You will see boron something like this, BF3, BCl3. So this BF3, if you calculate the electrons here of BF3, this is B, this is F, this is F, this is F. You know that it is having how many electrons? 1, 2, 3, 4, 5, 6. It is having 6 electrons. That means it is electron deficient. So others, as we go down the group, electron deficiency will decrease. Here it is having the maximum. That is why BCl3, BF3, they are very good Lewis acids. As well, we know that AlCl3, when it is not in the dimer state, it is also a good Lewis acid. Right? Okay, but because it can form dimer as well, that is why we consider it is less Lewis acid. Acidity is less. Right? Now, we have trihalides of boron. Now we have, if we focus only on the boron, we have BF3, BCl3, right? Now what about these trihalides? Which is having the maximum electron deficiency, right? So when we go down the group, we know that the size of this halogen is increasing, right? So what will happen here if you talk about Bi3, right? Bi3. Right, because the size of this iodine is more, right? That is why what will happen, its electron deficiency of this boron will be maximum in this case because of the electron cloud here. But if you talk about BF3, it is having the maximum electron negativity, but the size is very small, so it is having least, acidity is very less. But you know, from here the questions are rarely asked from Lewis acid order. Either they can ask you question from this stability of oxidation state. Next is they can ask you question from here, right? Okay, the reason for this one, right? The assertion reasoning question. They will firstly give you, this is the stability order. They can give you the opposite stability order also. Firstly, so you have to learn that, okay, whether that statement is true or not. Now, as I told you, down the group size is increasing, right? Either so they can give you that size is increasing, overlapping will be less, right? Okay, that is why electron will be very deficient. But you can also learn this with that this is 2p, boron is 2p. Here you have 2p, 2p overlapping. This is 2p, 3p overlapping, 2p, 4p overlapping. This is 2p, 5p overlapping. So if you talk about this is not, actually this is the reason for this also. There is another concept also. Okay. So what will happen here? Back bonding. So basically here we are talking about the overlapping. You can write here the overlapping. Okay. Overlapping, not the reason. This is the overlapping. Okay. So what you will observe here, 2p, 2p will overlap to a very good extent, right? Boron and fluoride will have a very good overlapping as compared to boron and iodine. That is why the back bonding will be, because more is the overlapping, more is the back bonding. That is why back bonding is more in BF3 as compared to Bi3. Okay. So this is also written here that back bonding order is inversely proportional to the Lewis acid order, right? Okay. Now more is the overlapping, less is the that means you can say that more is the overlapping, it will be electron rich. That is why electron deficiency will be less, right? So here you have more overlapping. More overlapping means it is not electron deficient. Boron is not electron deficient because overlapping is happening properly. Now, when you are meeting your friend, right, you are properly meeting them, right? Okay, you are eating lunch together, dinner together. So it means overlapping is good, right? You are having a conversation, right? When this boron and this fluorine is having good overlapping because of 2p, 2p orbital. That is why this boron is not alone. For example, you meet with a friend who is not a very good friend, right? Who just you just meet your friend and you're like, hello, hi, bye. When you will come back to your home, you will still feel alone. So this is the case for this Bi3. Here you don't have good overlapping. This is 2p and 5p overlapping. The overlapping is not good. That is the reason electron, because boron is having its own electron, iodine is having its own electron, because the overlapping is not good. That is why the electron are not that much there with boron. That is the reason. It is alone. It is very lonely. That is why it is electron deficient. That is why it is a very good acid. So two ways they can ask you the question. They can give you this assertion. They can give you this as the assertion, this as the reason, this as the reason, or they can individually ask you this, right? Okay, so two type of question can be formed from here. Next is basic character. If you talk about the basicity, basic character of the hydroxides. So as we go down the group, okay, this is as we go down the group, as I'm going down the group, what is happening here? As I'm going down the group here, what is happening? The hydroxide character is increasing here, right? Okay, the basic character is increasing here, right? Okay, because of this, basically this MOH bond here, right? This MOH bond here, right? Next you have atomic radius. Now this question is like a very, very important question. Very, 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 very important question. Again, this can be asked in your assertion reasoning as well. The order, as we go down the group, the size should increase, right? But here the order should be BALGA. It should be the order, but the order is GA is here and AL is here. Reason is inert pair effect. We know that in case of gallium, you have 3D electrons, and these 3D electrons have poor shielding effect. That is why they will contract, there will be contraction, the size will decrease, and hence the gallium will be over here. This is what I was telling you when I was teaching you shielding effect, that there are the exceptions are the answer mostly will be shielding effect or inert pair effect, right? So here this is the correct order and this is a very, very important order. Now this is the super duper important, super duper important, because here also I have written so many important here, right? So this is super duper important. The reason is this is very weird trend that you can see here. Basically it is based on this W. W is the way you learn this. Reason again is poor shielding effect of 4F, right? So basically one more thing here, in atomic radius now what will happen, this gallium will have 3D electrons. This thallium will also have 4F electrons, right? Because of these F electrons here, the size of this thallium will also be approximately equal to indium, right? Not exactly, approximately equal to indium. Now here, now again because of the inert pair effect and lanthanoid contraction, that means because of the poor shielding effect of D and F electrons, you will have this new order here, new trend here, which is asked so many times. So here it is. How to learn this? Basically thallium has come to the second point, and now gallium is after that, then you have aluminium, then you have indium. So it's everything is like scattered here, right? There is no proper trend that okay, there is one exception. There are so many exceptions here. So how to remember this? With the help of this W. So just draw this W, bar gaye Indian tail, you draw this. After this, what you do? This is B, after that you have GA, after that you have TL, after that you have GA, after that you have AL, after that you have IN. This is how you remember, B, TL, GA, AL, IN. Okay, B, TL, GA, AL, IN. That is the answer. Okay, yes, okay. Now, next is, this is a very, very important exception. Okay, very, very important exception. Next is metallic nature. If you talk about the metallic nature, always remember metallic nature, right? Non-metallic nature will increase along the period. Down the group, metallic nature will increase, right? That's why I didn't explain here, right? Now, because metallic nature is increasing down the group. Now, metallic oxides and hydroxide means they are the basic oxides. Metal means basic. Metal is forming basic things, right? That is the reason basic oxides, right? Basicity order is increasing down the group. Okay, because metallic order is increasing down the group, that is why basicity order is also increasing down the group, right? Okay, so now this is your metallic nature. As you can see, this boron is a metalloid. Then you have all the metals here. Boron is a metalloid. This you need to remember. Boron is a metalloid. Reducing power, right? Reducing power is Aluminium is maximum, then gallium, then indium, then thallium. Now that is opposite of basicity. See, acidity is opposite of basicity. Acidity and reducing power are similar only. Right? You just remember this thing. Basicity. Okay. Let me draw one thing here. Metallic character is directly proportional to basicity. Inversely proportional to acidity. Inversely proportional to reducing power. Okay. And here you can also say inversely proportional to non-metallic nature. So if metallic nature is increasing down the group, that means non-metallic nature is decreasing. That means acidic nature will decrease and reducing power will also decrease down the group. Right? Now, after that, you have these are so simple. Then you have metallic point, a melting point. Now, melting point also, gallium has exceptionally low melting point. It can also melt in our palm, right? In our hand also it can melt. It's such a exceptionally low melting point, right? Everything else is same. Thallium is before indium, right? Okay, this you can see from the table as well. Okay, this you can see from the table as well, right? Okay, guys. Next is group number 14. In group number 14, what do we have to do? NS2NP2. That means higher oxidation state is going to be +4. Lower oxidation state is going to be +2. That's why don't cram the oxidation state. Just remember, higher means both, take out electrons from both. Lower means take out electrons from only P. Okay. Down the group, lower oxidation state, stability will increase. That means +2 stability will increase down the group. And higher oxidation state stability will decrease. That is why it is decreasing down the group. Right? Okay. Till here we know. After that, ionization enthalpy. Right? If there is no exception in the size. Okay. I have written only the exceptional cases here. Right? So, size is not exception here. Now, ionization enthalpy. Now, guys, very important to see that everything else is same, but there is twist, change in PB and SN. It was supposed to be SN, then you have PB. Because we know that down the group, if size is decreasing, size is increasing, ionization enthalpy will decrease. Because size and IE are inversely proportional to each other. Right? So as down the group size is increasing, IE will decrease. So it should be Kasi Gaye Sant Prabhu. But it is Prabhu Sant. Right? That means it is opposite. Firstly you have lead, then you have tin. Right? So that is due to lanthanoid contraction. As I told you, always the reason is going to be lanthanoid, inert pair, all these things only. Right? Now let us see the density. Now the density we know down the group size is increasing. So molar mass is increasing. That means density should increase down the group. Yes. But the exception is with silicon and carbon. Silicon has more density as compared to carbon. Okay. Silicon has more density as compared to carbon. है ना? हाँ. If you're asking, ma'am, what is ionization enthalpy? Either to you are a student of 9th or 10th class or maybe 11th, right? Or you need to see me in JEE Mains 2026 preparation. Okay, chalo. Now, boron, because it is having very small size, right? It is always showing anomalous behavior. Right, very small size, it do not have vacant d orbitals. That is the reason it is forming covalent bonds also, right? And it is electron deficient itself, right? So that is the reason. Okay, chalo. Now next is thermal stability. Now thermal stability, this is in halogens. This is very, very important, right? That as we go down the group, the thermal stability will decrease. Of halogen, the thermal stability is going to decrease. That is so simple. That thermal stability means when you will heat it, it will easily dissociate. Now, if you talk about any metal, they are saying that if you talk about fluorine, chlorine, bromine, iodine, right? Again, the stability is decreasing. It is to that extent that PbI4 will not exist only. Very, very important. PbI4 does not exist. Okay, PbI4 does not exist. If they ask you the thermal stability of halides, it is decreasing down the group for one particular, for all the metals also down the group. In group number 14, it will decrease. But if you talk about any metal from this group number 14 and you attach different halides to this, then also down the group it is decreasing, right? Okay, so Pb is also least in that group, iodine is also least in that group, so both of them will not exist together, right? Next we have bond dissociation enthalpy. Now bond dissociation enthalpy, if you say, we are comparing this carbon with silicon, nitrogen with phosphorus, oxygen with sulfur, fluorine with chlorine, right? Now when we talk about carbon, carbon, silicon, silicon, we know that carbon, carbon has catenation. Carbon shows catenation property. That is why diamond is a very hard metal, right? So carbon, carbon bond are stronger as compared to silicon, silicon bond, right? And carbon also does not have any lone pair. Silicon group number, this group number 14 does not have any lone pair. But when you talk about this group number 15, group number 16, group number 17, here you will see that you have lone pairs. In nitrogen, group number 15, you have one lone pair. In oxygen, you have two lone pair. In fluorine, you have three lone pair. So what will happen with this lone pair? There will be repulsion, right? There will be repulsion. So what will happen? Basically, for example, you have nitrogen, and this is the lone pair. Down the group, we know that size is increasing, right? Size is increasing, then what should happen? The strength, the bond dissociation energy, they are saying, now as the size, down the group, we know that as the size is increasing, the length should increase and the bond dissociation energy should decrease here. But why it is increasing? Because of these lone pairs here. Because of these lone pairs here, they will interact with each other and hence you will have PP bond energy will be more. Similarly, sulfur having two lone pair, SS bond energy will be more. CCl bond energy will be more as compared to FF, OO and NN. Right? Okay, this they can ask you. Right? Okay, so this I have already told you that lone pair, as the lone pair is increasing, right? That is why more energy is required for that. Right? Okay, got it? Chalo. Now, next is catenation. Catenation, we know that carbon is having maximum catenation, down the group catenation is decreasing, right? Then you have, next is melting point. Melting point is, till here everything is right. But after this, again there will be a switch, right? Again, instead of Pb you have Sn, right? Okay, instead of Pb you have Sn here. Now, inert pair effect. Inert pair effect, we know that here you have FF electrons, that is why inert pair effect is maximum here, right? Here it is having only D electrons, so it is less, right? Okay. Now, next is group number 50, right? Okay, next is group number 50. Okay guys, just give me a second. There was also, I think, one more. Electron negativity. Based on electron negativity, the question has been asked. No? Okay. So, write electron negativity here as well. Okay, you can also write electron negativity here. Right. You can write electronegativity. Now, electron negativity usually it will increase along the period. It will decrease down the group. Okay. It will decrease down the group. So, it should be like this, but in reality it's not like this. Carbon is having maximum, then it is having similar, right? These all are having almost similar, then it is again increasing, right? Okay, so it is something like this. It is 2.8, 1.8, 1.8, 1.8, 1.9. Okay, got it? So this is the Electronegativity, this is your, I think, last year question. Okay, controversial question it was. Now, next we have group number 15, oxidation states, right? Group number 15, that is nitrogen family. Now in nitrogen family also very important thing, first is the stability of oxidation state. We have NS2NP3 is the electronic configuration, plus 5 is the higher oxidation state, lower oxidation state is plus 3, right? That is why if you talk about the stability of the oxidation state, in higher oxidation state, which will be more stable, nitrogen will be more stable, right? And in lower oxidation state, bismuth will be more stable, right? That is, wait a minute, higher oxidation means N5 positive, that will be more stable, right? Now we are having one more oxidation state, that is -3, and this -3 oxidation state is because of the electronegativity of this group, right? So when it has a less electronegative element, it will also show minus electronic configuration, minus oxidation state, and that minus oxidation state is going to decrease down the group. Why? Because electronegativity decreases down the group. Okay, because electronegativity decreases down the group, that is why it is not able to take out the electrons there. That is why -3 oxidation state will decrease down the group. Then you have thermal stability. It is same, that thermal stability is based on your overlapping, right? So here 2p overlapping, that means maximum overlapping, maximum stability. As we go down the group, overlapping decreases, hence thermal stability will decrease. Then we have, this we have done, boiling point. Boiling point is same, but in the end you will see a switch. Okay? Okay? In the end you will see an exception here for the boiling point. What about melting point? Melting point has even weird exception. First you have nitrogen, phosphorus, bismuth, then antimony, arsenic. Wait a minute. Okay? Chalo. Now after that you have, wait a minute, let me see the table here. Let me see the table. Was this the, wait a minute, where is the table? The table for group number 15, है ना? So this is the melting point. Melting point we were talking about, right? So maximum, then you have, let me just draw the melting point from this table. Melting point and boiling point. Let me write the melting point and boiling point from this table only. Right? Okay. Then we will verify. Right? Melting point is maximum. Right? Then you have, okay. ऐसे सब भी पन, ऐसे सब भी पन. Wait a minute, let me see, let me verify that. Oof, oof, oof. Melting point is right. Let me just see the boiling point here. I think boiling point is also right. Just confused about the melting point. Okay, let me just see the melting point and boiling point. Whenever you get confused whether the trend is right or not, just go through the NCERT, the direct question from the NCERT. The boiling point is maximum, right? This is boiling point is increasing, but here you can see the switch. Here you can see. So boiling point is also right. Okay, got it, guys. So that was the right trend only, right? So that is your trend for group number 15, melting and boiling point. Now, after that you have hydrides. Right now from hydrides the questions are frequently asked. So I'll just tell you a very simple thing about hydrides, that we will talk about 5-6 things here. First is stability, basicity, bond strength, bond angle, reducing power, acidity, melting point, boiling point of the hydrides. right? So if you talk about whether they ask you stability order, basicity order, bond length, bond strength order, or bond angle, this is always decreasing down the group, right? Stability, why stability is decreasing down the group? Because of the overlapping. Here you will have overlapping like 2p, this is 1s, this is having 1s with 3p, 1s with 4p. So that is why less overlapping will be there. Then you have basicity. We know that melting point, right? We know that whenever we talk about the basicity of hydrides, right? Firstly, you need to see this is a hydride. Okay, this is not a simple thing. This is a hydride here. So whenever we are talking about the hydrides, basicity means to accept the any proton, or you can say to donate the electrons, right? So as we go down the group, the electron negativity is decreasing down the group. So the power to donate the electrons, that will to increase. So it's not based on that basically. Yes, it is based on, wait a minute, acidity basis. Acidic strength is proton donor, right? So as we go down the group, the size increases. So listen. So firstly, though, we will talk about acidity. Basicity is opposite of that, right? So as we go down the group, what will happen? The size will increase, right? So as the size of nitrogen, phosphorus, arsenic, this will increase. The overlapping will decrease. This hydrogen, right? Basically, what is acidity or what is reducing power? To donate the proton, right? So here, proton donation will be easy because this is the order of acidity, then opposite is the order of basicity, right? Then if you talk about the bond strength, that so we know down the group what is increasing, bond now length is increasing because size is increasing. When size is increasing, strength is decreasing, right? Then we have bond angle. Now what will happen? Again, it will have 1 lone pair, right? Down the group, what will happen? The size will increase here, right? The length, bond length will increase here. Because of that reason, lone pair, bond pair, repulsions, right? They are going to change here, right? We know that bond angle will depend on the bond pair, lone pair repulsions on this lone pair and this bond pair that it will be forming, right? So more is the size as we go down. I have told you this even in the last session where I was telling you about the bond angle. Here we know that hybridization is same. Number of lone pair is same. Here the central metal atom is different, right? Central metal atom is different. So it will depend on the electronegativity of the central metal atom. As you go down the group, the electronegativity of central metal atom decreases. That is why the bond angle decreases. If you remember this, that I told you the exact concept in yesterday's lecture, right? Regarding the bond angle. For bond angle, first you will see the hybridization. Hybridization is same, then you will see the lone pairs. If lone pairs are also same, then you will see the electronegativity of the central metal. More is the electronegativity, more is the bond angle, right? Okay. Okay. Now this we have done. Melting point. Why melting point is decreasing down the group? If you talk about the melting point, it is decreasing down the group, right? Because the size is increasing, melting point is decreasing because of this strength, right? Then you have boiling point. Now for boiling point, we have a different scenario, right? Why boiling point has a different scenario? Because in NH3 you have hydrogen-hydrogen bonds. Between NH3 and NH3 you have hydrogen-hydrogen bonds. That is why it was supposed to be here, but it is here. Reason is the hydrogen bonding of NH3, right? Reason is the hydrogen bonding of NH3. Let me also show you that with the help of one table only, very, very important table, right? This is your hydrides. From here only I am picking all the trends, okay? So as you can see the melting point trend here, melting point trend, it is basically what is happening. Wait a minute, it is not exactly decreasing. Melting point trend is also little bit twisted, है ना? Melting point is maximum for NH3. Down the group it is decreasing, that we know. Then after that there is ASH3. After that there is SBH3. After that we have ASH3. Then we have pH3. That is the melting point trend. Okay, so just correct that thing. That is the trend for melting point, right? Okay, so that is the trend for melting point. But if you talk about the boiling point trend here, boiling point is it is maximum for SBH3, right? After that you have, not for SBH3, firstly so it is having BiH3, right? Then we have SBH3, right? Then we were supposed to have this ASH3, but we have NH3, right? After this we have NH3, after this we have ASH3, after this we have pH3. So reason for this switch is hydrogen bonding. Here you have the hydrogen bonding. Then you have EH distance, strength. We have seen that down the group size increases, length will increase. There is no exception here. Exception is in case of melting and boiling point. Then HEH angle, that also I told you that down the group the angle is decreasing, right? Reason, now here you will see angle is approximately similar only, right? But now this is a very important point. This is very important point, right? That here the decrease is very large. This decrement is very large. Okay, this decrement is very large. Okay, yes. Now the reason is little bit complicated here, that why the decrement is very large. Basically it is okay, if you want to know, then basically in NH3, right, after the third orbital what happens, in pH3 you have only S orbital which is overlapping, right? Here S orbital of phosphorus is overlapping with S orbital of hydrogen. This is extra knowledge I am giving you, right? This is sp3 is overlapping with S. That is the reason this decrement is to that large extent. Okay, that is the reason this decrement is very high, right? So this question can be asked in JEE Advanced. So we will do that when we have JEE Advanced. Now to just remember that there is very large decrement here that you need to focus, right? Next is delta. This is also very simple, that it will definitely increase down the group, right? That is formation energy. Dissociation energy will decrease down the group because bond length is increasing, bond strength is decreasing. So dissociation enthalpy will also decrease down the group. Okay, got it? Now wait a minute, let me again go to these hydrides where it was here, hai na? Now here it was, hai na? So now I think that's it for this one. Hydrides we have done. Now what about this bond angles? Melting point, don't do this from here, do this from where I have written it myself, okay, on the chart. Okay, don't do melting and boiling point from here, right? Now bond angle. Now down the group what will happen? If you have only one specific element, down the group, if you talk about the halides, the size of the halogen is going to increase, right? Because the size of the, see, I told you one more thing that, okay, for bond angle I told you one thing, that firstly so you need to verify what is the hybridization. Hybridization is same, right? That is sp3. If you see that lone pair is also 1-1 everywhere, lone pair is also 1-1. So lone pair is also not telling us the bond angle. Now if you talk about if central atom is different, then it is directly proportional to the electron negativity. But if surrounding atom is different, this is the central metal atom, if surrounding atom is different, then that is inversely proportional to the electronegativity. So now your surrounding atom is different, right? So in surrounding atom, the electronegativity is decreasing down the group. as the electronegativity is decreasing down the group, the bond angle will increase. This is a method to solve the bond angle. Okay, got it? Thank you, Crazy. Thank you, Crazy. Now, next is the acidic strength. As you can see, the acidic strength here. Acidic strength. Oxides of nitrogen, these are the oxides of nitrogen, right? First thing is, as the oxidation number increases, acidic strength will increase, right? So, this I have told you even in DNF block. So, now this is the same question, okay? They have also asked in JEE, they have asked for vanadium. Here they are telling for nitrogen. So, these kind of questions are also asked. As the oxidation state is increasing, acidic strength is increasing, right? Then, if you talk about this, in different element oxidation acidic strength is, if your element is same, here element is same. When the element is same, then as the oxidation state increases, acidic strength increases. But if your element is different, this is nitrogen, phosphorus, right? So, as the element is different, so what will happen? Acidic strength is directly proportional to the electronegativity. Electronegativity decreases down the group. That is why acidic strength will also decrease here, right? Now, let's talk about these two things. Here it is directly proportional to the acidity because central metal atom is same, right? So, oxidation state, if you talk about this oxidation state, this is NO3 negative. X minus X is equals to -1. This is X is equals to +5. Here it is +5 oxidation state. What about NO2 negative? You have X minus 4 is equals to -1. X is equals to, wait a minute. Array, it should not be that. X minus 6 is equals to -1. So, X is equals to +5 here. है ना? What about this? X minus 4 is equals to -1. So, X is equals to +3. Yes. So, it is +3 here. So, now more is the oxidation state, more is the acidity. But there is one exception here. The exception is this one. This is the exception. This is the exception. Right? So, here if you talk about this is PO43 negative. It is having X minus 8 is equals to -3. So, X is equals to what? X is equals to 8 minus 3, 4. 8 minus 3, 5. So, it is going to be 5 plus 5 oxidation state, right? What about H3PO3? This is PO3 3 negative, right? So, it is going to be PO3 3 negative. It is going to be X minus 6 is equals to -3. X is equals to +3, right? What about the third one? It is PO2 3 negative. That means X minus 4 is equals to -3. So, X is going to be +1. So, what should happen? Okay. So, what should happen here? More is the oxidation state, more is the acidity. This is what I was telling you, right? That means the answer should be this. More is the oxidation state, more is the acidity. But the answer is not this. The answer is opposite. The answer is opposite. That is why we have written exception oxo acids of phosphorus, and oxo acids of phosphorus are very important, right? I would not ask you to do full P block, all the structures, but yes, oxo acids of sulfur and phosphorus are very important, especially phosphorus, right? Reason is this. Now, as you can see here, you will have, because of this structure, not according to the oxidation state. Here, the maximum acidity is for H3PO2. Right, this is H3PO2. Why it is having the maximum acidity? Because it is having 2 hydrogens here. Here it is having 1 hydrogen. Here it is having no hydrogen. That is why more the hydrogen, more is the acidity. This is based on the structures, not based on the oxidation state. Got it? Yes, so that is a very, very important exception. Right? And oxo acids are to वैसे ही very important for you. Right? Okay. This I have written for hydrides. that if they ask you thermal stability or basicity or bond strength or bond dissociation energy, it will decrease down the group. If they ask you acidity or reducing power, it will increase down the group. Okay. Now, let us do the phosphorus acid, the structures here. From structures also they can ask you the question. Structure is very important for orthophosphoric acid, very important. Very important for hypophosphorus acid, very, very important, right? Then pyrophosphorus acid is not that important, but still you can do that. Firstly, so orthophosphoric acid and hypophosphorus acid are the most important, right? But you should go through all of them. Now, how to learn that? Always remember, phosphorus is always going to make one double bond O firstly. So when it is making one double bond O, PO is also already out of the situation. You are left with H3 and O3. So that is why you have 3 OH here. What about this one? Similarly, here, this is H3PO2. Firstly, make this PO bond, P double bond. Now, what you have after subtracting PO from here, you will have H3O, right? That is why you have only one OH here and 2 hydrogens here, right? So this is how to learn the structures. Others will have like H4P2O7 will have one oxygen, right? If you talk about this H4P2O5, it will also have one oxygen bond here, right? And this will also, this is a polymeric oxo acid. It will have a polymer of the oxo acid, right? So it will also have oxygen bridge in between them, right? So these are very important for you. Just make these structures, try to make it yourself as well, right? Okay. Now, next is group number 16. So for group number 16, what you need to remember, first is oxidation states only. This to beta NS2NP4, right? This to I have already done here as well. NS2NP4, lower oxidation state is +4, higher oxidation state is these two together, that is +6. Lower oxidation state will decrease down the group. That means PO2 positive will be maximum stable, right? And oxygen in +6 oxidation state will be very stable, right? Okay, that is the thing. But we never see oxygen is +6 oxidation state, right? Reason being because they are electronegative elements, right? They want to exist in -2 oxidation state. That is why -2 oxidation state is the most stable due to the electronegativity. And because electronegativity is decreasing down the group, that is why this is also going to decrease down the group, right? Thermal stability, it is based on the overlapping again. Down the group overlapping decreases, that is why it decreases. Here beta, here also down the group with hydrides as well overlapping is decreasing. That is why thermal stability is again decreasing here, right? Boiling point and melting point, the order is same, that is USC. Here we have switched the terms, right? That is important. Next you have bond angle, right? Bond angle. Bond angle, we know that that will depend on the central metal. As down the group electronegativity decreases, so bond angle also decreases, right? Acidic strength, that will depend on the oxidation state, right? More is the oxidation state, more is the acidic strength. So here acidic strength of SO3 is more. In this case, acidic strength of H2SO4, definitely this is sulfur is here it is SO4 2 negative. It is having more oxidation number, right? It is having X -8 is equals to -2, X is +6 oxidation state. Here it is SO3 2 negative. It is X -6 is equals to -2 +4 oxidation state. So more is the oxidation state, more is the acidity, right? Now, what about the halides? Here they are asking you the acidic strength again. Now, more is the oxidation number, more is the, ma'am, this is not applicable. Oxidation state is same, ma'am. Oxidation state is same, ma'am. Now what to do? Now we know that acidic strength decreases, reducing power, sorry, not decreases, increases down the group, right? Okay, basicity decreases down the group, right? So acidic strength of these hydride will decrease down the group, right? So hydride, for this also you can write whether they has thermal stability, basicity, bond strength, BD, that will decrease down the group. Acidity or reducing power will increase down the group, right? Next, electron affinity, right? Electron affinity is inversely proportional. Now here why we are saying the electron affinity, because electron affinity is supposed to decrease down the group. That means oxygen should have maximum electron affinity. This is very, very important. Okay, this is very, very important, that oxygen should have maximum electron affinity, right? But oxygen is not having maximum electron affinity. Electron affinity is the gain of electron, because oxygen has small size. Down the group size is also increasing, right? So size is also increasing, right? So along the period size is decreasing. So as compared to group number 13, 14 and 15, group number 16 has smaller size. Smaller size, more electron, already have 2 lone pairs. So it does not need any one new electron. That is the reason oxygen here is having least electron negativity. Reason is repulsions of the lone pair on that small oxygen atom, right? Okay. Okay. Next is hydride. I have already told you, simple. Then we have bond angle, right? Bond angle of H2O, right? Not bond angle, sorry, boiling point. Boiling point, we know that it is supposed to increase down the group. But H2 is having maximum boiling point. Again, the reason is hydrogen bonding, right? Because of hydrogen bonding, which is very strong, that is why boiling point is more for H2O. Okay. Then we have group number 17. For group number 17, we have electron affinity. Group number 17 is having some very amazing exceptions here, right? First is electron affinity, electron gain enthalpy, right? Now electron affinity, or if you talk about the electron gain enthalpy, that is firstly maximum. See, we know that electron affinity is supposed to decrease down the group, not decrease, decrease down the group, right? But what will happen? Why fluorine is not having the maximum electron affinity? Same reason, because it is having 3 lone pair of electrons, 3 lone pairs, right? And fluorine has a smallest size. So that is why electronic repulsions, and hence it does not want to gain any electrons. So this is a very, very important thing. Reason is also very important. Then you have bond dissociation energy. Again, fluorine wants to be the first person. Again, now what happened? Fluorine was like, I want to be here. I want to be number 1. है ना? Fluorine, chlorine, bromine, iodine. अरे भाई, fluorine is saying that down the group size is increasing, right? Bond length is increasing, ma'am. So bond dissociation enthalpy should decrease. That means to break that bond, you require less energy. But fluorine is at 3rd position. Reason? Because of electronic repulsion, already the bond between F and F is poor. That is why it is very explosive in nature, right? Okay. Then what about thermal stability of hydrides? Yeah, this is the same. 2p, 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 3p, 2p, 4p, 2p, 5p. Less is the overlapping, less is the thermal stability, right? Okay. So next is acidic strength. We know that acidic strength will increase down the group. Reducing power will increase down the group, because size of I is increasing down the group. It is easy to donate the hydrogen H positive. Basicity will decrease down the group. Thermal stability decrease down the group. Bond angle decrease down the group, right? Bond strength decrease down the group. Okay. So what about this? HClO, HClO2, HClO3, HClO4. Again, because of the oxidation state, you can see here it is ClO, X is equals to -2 is equals to -1. So X is equals to +1. Right? Chlorine is in +1 oxidation state. Here ClO2 negative. That means X -4 is equals to -1. X is equals to +3. Here it is +5. Here it is +7. Right? You can calculate that as well. As the oxidation state is increasing, acidic strength is increasing as well, right? Reducing power. Reducing power is same as acidic strength, right? Now, next is boiling point. Boiling point and melting point. Wait a minute. Boiling point, chlorine, bromine, fluorine. Wait a minute. Let us see this. Boiling point. Here though we don't have the boiling point. Chalo, no worries. Dekho, here they have told you about F2Cl2 Br2I2. है ना? That is what I have explained. Right? Now, next is this one. है ना? Next is the hydrides. This so I have already told you. Same. Thermal stability, basicity, bond strength, bond dissociation energy will decrease. Acidity and reducing power will increase down the group. Right? Bond length, we know that it is increasing down the group. Right? Bond length is increasing. Na? Length is so definitely increasing down the group. Right? Oxidizing power, if you talk about the oxidizing power, that is decreasing down the group. Right? Reducing power is increasing, oxidizing power is decreasing. Right? So here there is oxidizing power. So oxidizing power is inversely proportional to the oxidation state, right? Oxidizing power is inversely proportional. What about the dipole moment? Dipole moment of CCl, then you have CF. Again, here you can see one exception. Fluorine is most electronegative. Carbon is less electronegative. Still, its dipole moment is less as compared to CCl. Right? Again, because of small size of fluorine and electronic repulsions. Right? It is not able to gain that much electron here. That is why the dipole moment, the difference in the electronegativity is less. Right? Okay. So this is the end result here, that acidic is inversely proportional to basicity, reducing is inversely proportional to oxidizing power, inversely proportional to thermal stability, inversely proportional to bond strength, and inversely proportional to bond dissociation energy, directly proportional to bond length. Right? Okay. Now, this though we have done. Okay. Now I'll just show you some important tables here. Right? These are the oxoacids of sulfur, because they have asked so many times oxoacids of phosphorus. So just have a look at oxoacids of sulfur as well. Right? Okay. Then this the table I have explained you. Now from this table also they have asked direct question in your JEE. Right? That when you have XX3 type of interhalogen compound, it is having bent T shape. Right? When you are having XX5 kind of halide, it is having either IF5 will have square shape, square pyramidal. BRF5 will have square pyramidal. All of them are having square pyramidal only. So you can just write square pyramidal. XX7 will have pentagonal bipyramidal shape. Okay, so you can just see, just remember the shapes here. Right? Okay, chalo. Now let us do the questions of P block. Okay, let us start with the questions of P block. Guys, let me know in the comment section if you're ready for questions of P block or not. Questions of P block. Okay, now starting with this one, given below are two statements. First is SiO2 and GeO2 are acidic, while SNO and PbO are amphoteric in nature. Now they are saying you have two oxides, SiO2, and for this now I have very important thing for you. Just give me a second, okay? Just give me a second. I am importing one file here. We'll say, ma'am, how many notes you have already prepared? Just give me a minute, because I have prepared 2-3 slides for neutral, acidic, basic slides. No? This is the handwritten notes of periodic classification. Let me know if you want this, then I'll send you on the Telegram channel, right? Or I'll upload it somewhere. So many slides I have to delete, huh? Oof. Oof. Where are you, bhai sahab? This trend I am leaving, okay? This trend I am leaving here. These are not in your P block, right? Some trends I am leaving here. Okay. Now we have 3-4 things here. I'll just go through that fast, right? So basically, there are few points to remember, guys. Okay, so just let me show you that. First is to this one. So this is basically your along the period trends, hai na? They can also ask you these trends, right? Okay. Now they can also ask you these trends. Okay, so that is your along the period, right? Lithium, beryllium, boron, carbon. Now they are talking about basically, wait a minute, yes. So here though the size is increasing. Here they are talking about the ionization enthalpy. Okay, this is the trend of ionization enthalpy. I'll just write it here because this is important exceptional trend. So that is why, because we are doing the full block chemistry. So in periodic classification, most of the things are repeated in your D and P block, right? But there are 2-3 trends that are not mentioned in your P block and D and F block, right? So this is among them. Basically, along the period, ionization enthalpy increases or decreases. Size is decreasing, IE is increasing down along the period. But the exception is with this one. Here, lithium, beryllium, boron, carbon, nitrogen, oxygen. Then why we have switched these two things? Because beryllium has fully filled. Beryllium is having 1s2, 2s2. Nitrogen is having 1s2, 2s2, 2p3. So fully filled and half filled orbital they are having. That is why to take out electron from fully filled and half filled, it is very difficult. That is why here beryllium has more IE as compared to boron. Nitrogen has more IE as compared to oxygen. And similar is for this sodium, aluminium, magnesium. Similar is for potassium, gallium, calcium. Right? Okay. Same trend it is following. Usually they will ask you for lithium. They will ask you from lithium, beryllium, boron. Now, boron family, these two trends so we have seen in P block. This we have done in P block. Okay, this we have done in P block. So you don't need to do it here. Next, this trend, this is your, wait a minute. Lithium, beryllium. This is not important for you, though it is electron affinity. Okay, this is a trend of electron affinity, right? Now, basically, this is a very, very weird trend, right? So, as you can see here, neon, beryllium, nitrogen, boron, lithium, carbon, oxygen, fluorine. There is no as such proper pattern that we can see here. That, okay, this is one switch, this is second switch. There is as such no pattern here, right? That is why I am telling you that if they want to ask you a really difficult paper, then they can ask you this. Otherwise, I can say that this they can ask you in JEE Advanced. In JEE means I feel less chances are that they will ask you this tough exception, right? Usually common exceptions are asked, right? So this is a very tough exception. This has not been asked in JEE, but Yes, you can just go through that. What if they ask you this in JEE Advanced? Have the chances that they can ask you this exception, right? Now in third period, more affinity than second period, right? Electron gain affinity we are talking about, that third has more, and I think that's it. Okay, now let's talk about the exceptions here as well, right? So you can just go through the exceptions here. In halogens you have electron affinity exceptions, है ना? You must have seen this. This so I have told you, है ना? We have just seen these exceptions in P block. We have seen that in second period there is exception, in third period there is exception, है ना? In halogen there is exception. Fluorine because of small size, it does not want to gain. Oxygen because of small size, it does not want to gain. So mostly these two are very important electron affinity exception. Right? These two are most important electron affinity exception. Okay? Yes, definitely you can watch this. Now acidic strength of hydrides, this I have already told you that down the group acidic strength will increase. Right? I have just combined all these things together, acidity and basic strength. Okay? Basic strength of hydrides, that will also increase, right? Along the period basic strength decrease, along the group also basic strength will increase, will decrease. And this is a very important point to note down, that along the period also basic strength will decrease, along the group also the basic strength will decrease. Along the period basic strength is decreasing due to electron negativity. Along the period basic strength is decreasing due to size, right? Okay, next we have hydroxides. So hydroxides are like metallic, right? So if you have if you talk about basicity, that is dependent upon the metallic character. Down the group metallic character increases, so basicity will increase. Non-metallic character is directly proportional to acidic character. Okay, down the group non-metallic character decreases, acidic character will also decrease. Same thing we are writing, that along the period metallic character it is decreasing, along the period metallic character is decreasing, non-metallic is increasing. Metallic is decreasing, that means basic strength is decreasing, acidic strength is increasing. This you have to remember, that's it. And remember one thing, that along the period metallic character decreases, down the group metallic character increases. From there you can easily conclude this thing, right? Now the same thing, I have just given you one example here, that lithium, beryllium, boron, aluminium, this is along the period basic strength will decrease. This is down the group, beryllium, magnesium, calcium, strontium, here they are talking about acidic strength. Basic strength is, wait a minute. Basic strength is, down the group metallic character is increasing, basic character is increasing. So yes, basic strength is also increasing. Here it is decreasing, here it is increasing. Right? Okay. Next is oxides. This is what I wanted to tell you, that basically you have four kind of oxides: neutral, amphoteric, acidic and basic, right? So the questions are directly asked from acidic, basic oxides. So what you have to remember in your exam is this thing. Okay, so this is a very for boards it will be too much for you. For boards it will be too much for you. Okay, so very important. Basic oxides are sodium, magnesium, calcium. Acidic are carbon, sulfur, phosphorus. Amphoteric are all-jan, Vakar, Pub, Sun. Okay, you can see, you can just say that all-jan, all janta means all, sabhi log, right? All janta, Vakar, all janta, Vakar, Sant Prabhu, right? Like everyone is going to Sant Prabhu. All janta we kar Sant Prabhu. Okay, you just remember this. A you have, this is amphoteric, zinc also amphoteric, vanadium also amphoteric, chromium also amphoteric, lead also, two oxides are amphoteric, tin also, these two oxides are amphoteric. From here your JEE question has been asked. Okay, very important. Neutral. Neutral are these three oxides, CO, NO and N2. These three are your neutral oxides. So this is a very important thing. Okay. and that's it. Other तो you don't have to do, right? That was for something else. Chalo, if you want to do, I can also teach you that. Chalo. Okay, so again, if you talk about the oxides, along the period, what will happen? Along the period, acidic oxide increases. Along the group, basic oxide increases. So based on that, if you have basic character also, acidic character also. This is you have down the group, right? Acidic character is increasing. Wait a minute. Acidic character is decreasing down the group. Hai na? It is decreasing. Down the group, acidic character will decrease, right? So this is down the group. This is down the group, okay? This is again down the group. Down the group, if you talk about the basic character, that will increase. So that is why it is increasing here, right? So these are the simple direct relations I have written here so that you are able to understand, okay? So from this only you will get so many questions in JEE. So acidic strength, sometimes we teach this in classification of periodicity, classification of periodic table as well. This is basically a part of block chemistry. You can learn this anywhere. D block, P block, classification of periodic table, wherever you want to learn. So acidic strength is directly, now very, very important. Acidic strength, if you have oxides of same element, as I told you, it is directly proportional to number of oxygen atoms, or you can say the oxidation state. More is the oxidation state, more is the oxygen atom. Okay, more is the oxidation state, more is the oxygen atom. So directly I have written this. If you have same central metal, then number of oxidation number, right? So more the oxygen number, more is the acidic strength, right? Now, next is acid and its anhydrides. Anhydrides means you have to take out water from here. So, take out water, you will have SO3. Take out water, you will have SO2. Here, take out water, you will have CO2. Take out water, you will have HNO3. Take out water, here you will have 2 of this and 2 of this. You will have N2, 2 nitrogens. From 6 oxygen, take out 1 oxygen, it will be 5. Why I have added one more molecule? Because I need to take out water, anhydride, 2H I need to take out from here, right? Here also you need to have 2 molecules of HNO2, take out 2 hydrogens, right? Then you are left with 2 nitrogens and 3 oxygens. Okay, understood? Okay, guys. So this is the acidic strength of oxo acids. This also I have told you that oxo acids, as you can see, mostly what will happen, right? It will, you have sulfur selenium, right? So here it is decreasing only, right? That means along down the group it is decreasing, right? Down the group you see acidic strength is decreasing, but along the period it is increasing. If you see along the period, this is carbon, phosphorus, sulfur, chlorine. Along the period, it is increasing. This is down the group. Okay, this is down the group, it is decreasing. Down the group, it is decreasing. Along the period, it is increasing. Right? Okay, chalo. Next is some central metal atom. So more, again, I have told you that more is the oxidation, acidic strength is directly proportional to the oxidation state. More is the oxidation state, that means more the number of oxygen atoms. So that is why we have this. This exception also we have done, that this is based on the structure. Okay, this is based on the structure. So these things so we have done. Chalo. Now I think theory part so we have completed. Hana, the student who have watched this lecture with patience, na, he will definitely get good marks in block chemistry. Okay, chalo. Now let us see questions from P block. Now we are only left with the questions. How's the Josh in the comment section? Huh? Ma'am is teaching at 11 p.m. Still the energy is very low. Still the energy, ma'am. Energy, you guys. Energy is very low, huh? Okay. Given, do you want me to complete this or you want to sleep? Do you want me to complete this? Or you like, ma'am, we are dead tired, ma'am. We want to sleep, ma'am. Huh? What do you want to do now? Theory part we have done. We are only left with P block. My throat is totally dead right now. Yes, bachcho. The chat is not moving only. Huh? Sometimes I feel sad for myself that why I am standing here. What's the use? Our students even I to sometimes feel you don't want to study only. Huh? Chalo, do you want me to not do the previous year questions? Hmm? Do you want to do previous year questions or not? I am waiting for your reply, guys. I had told you, I don't have power. I don't have, I am not a superwoman. We can read your minds through camera. Hmm? I am a normal person, guys. I can't read your mind. You need to tell me, you need to type. है ना? You to behave like a girlfriend. है ना? जैसे girlfriend like, I will not speak anything. You understand? I will not speak anything. You only understand. I'll give you hints. So you are giving me hints like that. Ma'am, we will give you hints. You understand yourself, ma'am. Ma'am, maybe try avoiding teaching so late. Of चलो ठीक है. Now I'll teach at 5 p.m. only, है ना? Do previous year questions, ma'am. Chalo. So I want to see the energy in the comment section, okay? So given below are two statements. They are saying given below are two statements. Statement 1 is SiO2 and GeO2 are acidic while SnO and PbO are amphoteric in nature. Okay. So SN2 and PbO are amphoteric in nature and Si and GeO that are acidic in nature. That is so true. Allotropic form of carbon are due to property of catenation. Now carbon is forming carbon-carbon bond, multiple bond, but carbon does not have d d orbital. So it cannot form d pi p pi. It can only form p pi p pi. So this is false. So answer is first is true, second is false. So third is the correct answer. Right? Third is the correct answer. Next we have given below are two statements. Assertion is melting point of boron is unusually high in group 13 elements. Assertion is melting point of boron is unusually high in group 13 elements. Okay. Solid boron is very strong crystalline lattice. This I have told you that boron is a very small, it's a very small atom, right? So it is a very small element. That is why it is forming covalent bond. So that is so true. And that is what is having unusually very high boiling point. That is also true. So answer will be A. Both A and R are true. And no, both A and R are true. And R is the correct explanation of A. So answer is second is the correct answer. Right? Okay. Huh. Identify the incorrect pair for the following. Right? Fluorospar. This to first is only incorrect. Right? Fluorospar is a calcium fluoride. Right? So answer is first is the correct answer. Rest of them are right. Cryolite, fluoroapatite, carnellite. Right? Next we have consider the following oxide group number 14 element. Okay, again from this neutral oxide, hai na? So the amphoteric oxides are, this I told you that Pb and Sn will have amphoteric oxides, right? Sant Prabhu, right? So answer is Third is the correct answer. Chalo. Next question is, given below are two statements. So they have given you two statements here. Group 13 trivalent halides get easily hydrolyzed by water due to their covalent nature. ठीक है. That is true. Group 13 trivalent halides, that means they are talking about BF3. They will easily get hydrolyzed because they are covalent in nature. That is so true. AlCl3 upon hydrolysis in acidic aqueous solution forms octahedral. This is also true. है ना? But these statements are true. They are not reason for each other, but both the statements are true. So both the statements are true. Fourth is the correct answer. Right? You will see most of the questions are assertion reasoning only. Right? Next is the number of neutrons present in more abundant isotope of boron X. What is the most abundant isotope of boron is 11. Number of neutrons here, more abundant, wait a minute. The number of neutrons present in more abundant isotope of boron, hydrogen, lithium, beryllium, boron. Okay. Amorphous boron upon heating with air forms a product in which the oxidation state of boron is Y. Oxidation state will be, I think, 4, right, or 3, right? Oxidation state. It is forming upon heating with air, it is forming a product, right? So boron cannot expand its valency, right? Boron is having 3, so its valency will remain 3. So I think the answer should be, wait a minute, let me see. Boron is 11, number of, boron is B11. B11 means number of neutrons plus protons, right? So protons, hydrogen, helium, lithium, beryllium, boron. So 11 minus 5 means how many? You have 6 neutrons here. Because protons are 5. So 11 minus 5 is what? These are your neutrons. Neutrons are 6. So neutrons are 6 after this, because boron cannot expand its valency beyond 3. So its oxidation state is going to be 3. So 6 plus 3, it is going to be oxidation state here is going to be 3. So 6 plus 3 is going to be 9. Okay. So answer is going to be second is the correct answer, right? Okay. Chalo. Next is the correct statement from the following. The decreasing order of atomic radii of the following group is this. Okay. Radii they are asking. Radii they are asking. Down the group 13, electronegativity decreases from top to bottom. That is so true. Al dissolves in dilute HCl, liberates H2, but concentrated HCl renders Al passive by forming protective oxide on the surface. Liberates H2, but concentrated, this is also oxidizing agent, so it will form a passive layer on aluminium and it will not get oxidized by that. So answer this is also true. Basically till now we have B and C as true. B and C as true are only in fourth option. Are only in fourth option. So all the elements, right? All the elements of group 13. Wait a minute. Down the group electronegativity decreases from top to bottom. That is also right. All the elements of group 13, I think the answer should be 4 only. All the elements of group 13 exhibit +1 oxidation state. Group 13 तो will never exhibit +1, so D is not the correct answer. Hybridization of Al in this is sp3d2, that is also true, right? So I think fourth is the correct answer, है ना? C and D. Wait a minute. Down the group 13, electronegativity decreases from top to bottom. Electronegativity, group number 13 is, wait a minute, Acha, there is one exception also here, na? Wait a minute, let me tell you the exception here. There is one exception here. There is one exception. You can just write down the exception here. This is based on the exception only, है ना? Because the decreasing order of atomic radii of group 13 is definitely wrong, because group 13 will have variation in GA and AL, है ना? So down the group, the radius will increase. Increase, but there will be variation in aluminium and gallium, not that much, है ना? So here, this is going to be wrong, right? This will be AL and GA. Firstly, to this thing. So this is your false, है ना? So now, है ना, हाँ. So this is exception. Here it is going to be. I'll just tell you how to write it, okay? I forgot to mention that. Now, firstly, we know that down the group electronegativity decreases. So firstly, you will have B, then you have TL, then you have IN, then GA, then AL. Okay, so that is going to be the correct answer. First you have B, then you have TL, then you have IN, then you have GA, then you have AL. Okay, this is how the electronegativity is not decreasing down the group, right? This is the general trend, but the actual trend is, firstly it is going to, the maximum is for boron, then you have thallium, indium, then you have gallium, then you have aluminium. Okay, so this is how it is. So answer, this is also false. So answer is only C and E are correct. So answer is third is the correct answer. Okay, 3 is the correct answer, right? Okay, chalo. Now next is the number of ions from the following that are expected to behave as oxidizing agent. Oxidizing agent means where oxidation number will increase. So there should be some reason for oxidation number to increase, right? Oxidation, which is behaving as oxidizing agent. Wait a minute. If they want to behave as oxidizing agent, their oxidation number should decrease, right? Okay. So we know that Pb4 positive, right? Okay, this is basically in the carbon, na? Wait a minute, carbon is having one NS2 NP2, right? So here carbon family will have lower oxidation state as +2 and higher as +4. So Pb, lead is the lowest member, right? So down the group, lower oxidation state stability increases. So it would want to get converted to Pb2 positive because Pb2 positive is more stable. And then if you talk about Ti3 positive, right? This is also more stable, right? This is in which group? Ti is also more stable in Ti positive, right? So it would also want to decrease the oxidation number. So I think the answer, number of ions should be 2, है ना? Number of ions should be 2. So Pb4 positive, this will function as oxidizing agent because they will get reduced to T, this and Pb2 positive, है ना? So Tl, है ना? Here you have thallium, okay? So thallium is going to be more stable in +1 oxidation state, right? Because down the group, if you talk about group number 13, this belongs to group number 13, है ना? This belongs to group number 14. Here it is NS2NP2. Lower oxidation state is 2, higher is 4. Here you have NS2NP1. Lower oxidation state is 1, higher is 3. So here also it is more stable in +1 oxidation state. So answer is TL and Pb. है ना? Next we have, evaluate the following statement related to group 14. Right, you have to evaluate these statements. Covalent radius decreases down the group. Covalent radius decreases down the group. Electronegativity decreases from carbon to Pb down the group gradually. maximum covalency of, see, all of them are including the trend. So electronegativity again is very important for you, right? So let me write down firstly the electronegativity of this, है ना? So it is wait a minute, Sn, and this is Pb. So they are saying that from Pb it is decreasing gradually. So it is not decreasing gradually, right? It is not decreasing gradually. Firstly, so this will be your false, है ना? B will be false. Then let's talk about C and D and E. If you see E only, then you will get the answer. Carbon can exist as negative oxidation state. That is also true. Heavier elements do not form p-pi bonding. Heavier elements do not form p-pi bonds. Heavier elements will form p-pi d-pi bonds. That is true. The maximum covalency of carbon is 4, where other elements can expand their covalency due to d orbitals. That is also true. C is also true. C is also coming out to be true. This is also coming out to be true. That heavier elements do not form p-pi, they will form p-pi, d-pi, because down the group they will have d orbitals. Here maximum covalency of carbon is 4. This is the first element. Other elements down the group can expand their covalency. That is also true. Covalent radius decreases down the group from carbon to lead. Now from carbon to lead, we have an exception trend. We have proper exception there, right? Because of inert pair effect, and in the end you will have the exception. With lead and tin, you have to switch it, right? So answer will be second is the correct answer, है ना? Because you will have this thing. Acha, the answer is not, I have not written the answer here, but you got na ki the trend is abnormal. There is one exception, right? Covalent decreases down the group. That is not true. That is false. Okay. So firstly, though, you will have to see all the things here. All basically they are asking you everything regarding the trends. Now you have the stability order of +1 oxidation state. In this, +1 oxidation state is lower oxidation state. That increases down the group. That is true, right? Inert pair effect stabilizes the lower oxidation state. Yes, because of inert pair effect only this was happening. So that is also the reason. So both are true and R is the explanation of A. So answer is third is the correct answer, right? Okay. What is this question? Among the following oxide of P block or D block elements, number of oxides having amphoteric. Now amphoteric, how many of them have amphoteric? This is amphoteric. This is amphoteric. This is amphoteric. 3 oxides are amphoteric. This is neutral, 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 right? So amphoteric, neutral, others are acidic in nature, right? That's why I told you that this is important for you to understand which are amphoteric, which are neutral. That's why I told you to learn that, okay? That page is very important for you that I have made for you. 1 mole of PBS is oxidized by X mole of O3 to get Y moles of O2, X and Y are. So basically it's a reaction based question. So you have PBS plus O3. It will give you, wait a minute, this will be O2, not SO2, right? It will give you 4 moles. Firstly, so you have to balance this equation, right? Now there basically, this is reaction, this is question from reaction only. They are saying that 1 mole of PBS oxidizes with X moles of O2. This is X means 4. And what is, it is having Y moles of O2, Y is also 4. So X plus Y is going to be 8. So answer will be 8. Okay. Next we have, from the given list, the number of compounds with +4 oxidation state of sulfur. +4 oxidation state. From here to here, you have to calculate the oxidation state of each of them. है ना? Easy. Very easy to calculate the oxidation state. Will you be able to calculate the oxidation state? I'll tell you for one. Let us talk about this H2S2O7. So here it will be, let's say it is S2O7, 2 negative, it will be 2x minus 14 is equals to minus 2, 2x is equals to 12, x is equals to 6. That is going to be the oxidation state, right? If you talk about this one, it is SO4, 2 negative. So it is x minus 8 is equals to minus 2, x is equals to plus 6 again. This is number of compounds with plus 4 oxidation state they are asking. Now this will have plus 4 oxidation state. It will have x minus 2 is equals to 0. So it will be x is equals to plus 4 oxidation state. Here SO3, this is SO3 2 negative. X minus 6 is equals to minus 2, x is equals to plus 4 oxidation state. Here it is x minus 6 is equals to 0, it is having plus 6. So how many of them have plus 4? 3 have plus 4 oxidation state, right? Okay. Chalo. Okay, these 3 have plus 4 oxidation state. Next is element not showing variable oxidation state. Now guys, fluorine is the most electronegative. It will show the element that has, for example, there is one Don. Again, he is scared of, like he is not scared of anyone on this planet. Fluorine is that Don. Right? So he is never electropositive. So it cannot change its oxidation state. So answer is fluorine. It does not have variable oxidation state. Right? Next we have oxygen being first member. Let us see how many questions. Too many questions. Still, chalo, koi baat nahi, we'll do that. Chalo. I will not write the answers now. I'll just show you the answers and we'll just proceed with that, because otherwise it's very time consuming, right? So now let's speed it up. Oxygen being first member of group 16 exhibit minus 2 oxidation state. Down the group 16 stability plus 4 oxidation state decreases, plus 4 oxidation state increases. That is false. That is true. First member exhibit only, that is also false. It does not exhibit only minus 2 oxidation state. So both the statements are incorrect, right? Both the statements 1 and 2 are incorrect, right? Next we have, they have already the answer is written. The stability of hydrides decreases in the order this. Okay. So if you talk about the stability, thermal stability will decrease down the group. Reducing nature will increase down the group, right? So it is increasing. That is also true. This is also true. This is also. Among the hydride, NH3 is strong reducing agent. Here we have written that reducing ability is increasing. That means this is having weak reducing power. So this is false. The basicity of hydride, basicity is similar to opposite to acidity, right? So if acidity is this is increasing. So basicity will decrease down the group. So answer is, this is also false. Only A and B are the true options, right? Next you have statement. Noble gases, wait a minute. Noble gases have very high boiling points. That is true. No, they will not have very high boiling points. Noble gases are monatomic gases. They are held together by strong dispersion forces because they are liquefied at very low temperature. They have very high boiling points. Wait a minute. Noble gases are monatomic gases by strong dispersion forces. This is also false. Boiling point, noble gases are held together by van der Waals forces, right? So both the statements are false. So answer is D is the correct answer. Okay, noble gases have very low boiling point, right? So you can easily break the van der Waals forces, right? Now choose the correct statement out of this. Group all the group 16 elements of oxides of general formula EO2, EO3, where E is equals to this. Now they are saying all group 16 elements form oxides of general formula this and this. Okay. Both the type of oxides are acidic in nature. If you talk about group number 16, O2, 16, SO2, SO3. Okay, yes, they are forming that. TO is an oxidizing agent while SO2 is reducing in nature. PeO. That means it is in Te2 positive state. It is in S2 positive state. It is more stable in, wait a minute. The reducing property decreases from this and this down the group. Reducing property increases, this is also false, right? The ozone molecule contains 5 lone pair of electron, that is true. है ना? This is true. I to feel A and D. A and D. I think A is the correct answer because all of them are going to be wrong only, right? TeO2 is strong reducing agent. Why? Because Te is existing in Te2 positive. It is stable only, it is happy because down the group oxidation, lower oxidation state is more stable, right? Okay, so let us see. A will be the correct answer, right? Reducing property increases from this and this. So A and B, what is the asking the correct statement here? A and B. Group 16 element, a general formula this. A is definitely true. Ozone molecules have 5 lone pair. That is so false, na? So wait a minute. What I have written here? I have written false here. So sorry guys. I think my bad. It was having 6 only. In my mind, it was 6 only. I don't know why I have written true. It was false only. Right? So A and this is, wait a minute. Let me see TeO2 and SO2. This is SO2. This is TO2. Right? Down the group we know that oxidizing power will increase. Acha, theek hai. That is based on some other concept. Okay, I'm so sorry about that. So down the group oxidizing nature will increase, that I have told you when I was showing you the notes, right? So I have told you that down the group oxidizing power will increase and reducing power will decrease down the group, right? So from that concept we have the comparison of TeO2 and SO2 in the same group. So down the group the oxidizing power always increases only, right? So here next we have is, okay, next we have is identify the incorrect statements about group 15 elements. Okay, nitrogen is diatomic gas which acts like an inert gas at room temperature. The common oxidation state of these elements are -3, +3 and +5. Okay, nitrogen, they are asking the incorrect statement, na? So these are the correct only. है ना? Nitrogen has unique ability to form p-pi multiple bond. Nitrogen can only form p-pi bond because it does not have d orbital, right? Next is the stability of +5 oxidation state increases down the group. This is false because lower oxidation state will increase. Nitrogen shows maximum covalency of 5. This is also false. So D and E are false, right? So answer will be C is the correct answer, right? Next you have, now they have given both rhombic and monoclinic sulfur exist as S8 while oxygen exists as O2, okay? Oxygen form p-pi multiple bonds with itself and other elements. However, small size and high electronegativity like C and N is not possible for sulfur. Basically, they are saying that oxygen is having multiple bond, only O2, right? But sulfur is having S8. That is true. Now they are saying that oxygen forms p-pi. This is also true with itself and other elements having small size. That is also true. That oxygen can form p-pi bond with itself and other molecules, which is not possible for sulfur because sulfur is having d orbitals, hai na? So it will form d-pi bond. So I think answer will be C is the correct answer, hai na? Because it is forming. Arey yaar, why it is going to be wrong? Why it is getting wrong? Oxygen can form p-pi multiple bond with itself due to smaller size. Sulfur cannot form multiple bonds, will be unstable due to large size of sulfur. Then this is what they have written here. Oxygen forms p-pi multiple bond with itself and other elements having small size with high electronegativity, which is not possible for sulfur. So that statement is also right. Then why here which statement they are saying is correct? A is correct but R is not correct. How come R is not correct? Oxygen form p-pi multiple bonds, है ना, with itself due to small size, while sulfur cannot form multiple bonds with itself, as 3p-pi bond will be unstable due to large size of sulfur. But sulfur can form multiple bond with smaller size like carbon and nitrogen, right? And here what they have written, something weird we can see here. Wait a minute. Oxygen form p-pi multiple bonds with itself and other elements having small size and electronegativity, which is not possible. Acha, this is the wrong statement. This one is the wrong statement. This is the wrong statement. Because sulfur can form bond with carbon and nitrogen. So it's not that sulfur cannot form multiple bonds. It can form multiple bonds, but it should have very small size and high electronegativity. But with oxygen, this is not the case. With oxygen, it can only form p-pi bond, right? Because it does not have d-pi orbitals, right? So yes, this is the wrong thing here. This thing is wrong here. That high electronegativity like carbon and nitrogen, it can also, sulfur can also form bonds with carbon and nitrogen, but not with all of them, right? So answer yes, R is not the correct statement then. So A is correct, but R will be incorrect. So this is very important. A very chotu sa line they have hide it somewhere. Now this is the wrong statement. Okay? Yes? Chalo. Now next is on reaction with lead sulfide with dilute nitric acid, which of the following is not formed? Right, there is nitric oxide, nitrous oxide, lead nitrate and sulfur. Which of the following is not formed? So as you can see here, PBS and HNO3, when it reacts, it is forming NO. So nitric acid is formed, nitrous oxide is not formed, right? Nitric oxide we are forming here, right? Next we have number of oxygen atoms present in chemical formula of fuming sulfuric acid. Basically oleum they are talking about. So oleum, if you talk about the oleum, fuming sulfuric acid, right? How many oxygen atom it is having? It is having 7 oxygen atoms. So simply answer will be 7, right? Oleum is nothing but it is fuming sulfuric acid, okay? Now next we have reducing. Now this is questions based on oxo acids, right? Reducing, strong reducing behavior of H3PO2 is due to. If you talk, this lies in the structure. If you talk about the structure, that's why I asked you to learn the structures here. Right? As you can see the structure here, wait a minute, as you can see the structure here, here you have 2 hydrogens. Because of these 2 hydrogen, it is showing very good reducing power. So presence of 1 OH and 2 pH bond is the reason. So answer will be A is the correct answer, right? Now again, this is a question on again phosphorus oxo acids. Which of the following statements is not valid for oxo acids of sulfur? Orthophosphoric acid is used in manufacture of triple phosphate, right? That is true. Hypophosphorus acid is diprotic acid. They are asking you not valid, like invalid statement. So if you see the structure of hypophosphorus acid, this is hypophosphorus acid. Hypophosphorus acid, the protic nature will depend on the OH. So you have 1 OH means it is monoprotic, right? So that means second statement is incorrect. Hypophosphorus acid is diprotic in nature. Okay. Now next is, that is the incorrect statement. Next we have pure nitrogen is prepared in the laboratory by heating mixture of. Pure nitrogen, reaction based question. Okay. So that is prepared by heating NH4Cl and NaNO2, you will get pure nitrogen in the laboratory. So answer is going to be D, that is NH4Cl and NaNO2. Next we have, which of the following statements is not correct for nitrogen, right? Nitrogen is, its electrons is very high, d orbitals are available. No, which of the following is not correct? D orbitals are not available for bonding. It's the first element, right? So d orbitals are not available for bonding. Next we have, of the following, very important, of the following hydrides, which one has lowest boiling point? So if you talk about the hydrides, right, the boiling point will decrease, right? So here they are talking about lowest, Bi does not have, SB, I think boiling point, na? So boiling point has a boiling point was not like this. Boiling point has a different, there was a different trend for boiling point, hai na? What was that trend? The trend for boiling point was this one, hai na? That was a very unique trend. It was not a same trend, it was like this, hai na? NH3 due to hydrogen bonding, NH3 due to hydrogen bonding, it was in between it, right? So here you can see the lowest boiling point is for pH3. It was supposed to be NH3, but it is pH3 because NH3 is having hydrogen bonding. So answer is C, pH3. Okay. Now that will be same for oxygen family also. It was supposed to be H2O, but in H2O you will see hydrogen bonding, right? Now next is, nitrogen forms N2 but phosphorus is converted into P4 from P. The reason is, triple bond is present between phosphorus atom, P-pi bonding. P-pi bonding is multiple bond is formed easily. Okay, so N2 cannot expand its octet. That is the firstly reason. Phosphorus converted into P4. The reason is bonding is weak. Triple bond is present between phosphorus. That is not true. Multiple bond is formed easily. P-pi bonding, it will depend on the P-pi bonding, na? So nitrogen forms N2 but phosphorus P4 because P2 P-pi bonding is present, which is weaker bonding. Okay, so that is why the answer is going to be C. P-pi bonding, which is a weak bonding, so it is going to form four, like it is going to form rhombus, right? Rhombic structure, right? Like that. Then we have, that is why you will have white phosphorus, red phosphorus, different kind of phosphorus forms you will have, right? Which out of which rhombic is stable. So strong reducing behavior of H3PO2 is due to. Now then you have to see the structure of H3PO2. Now as you can see, it has two hydrogens. That is why it is having strong reducing behavior. I think this question is repeated, hai na? So this is A is the correct answer. Then you talk about, which of the following statement is not valid for oxo acids of sulfur, of phosphorus? As I told you, oxo acids, I think this is repeated again, is it? Hana, this is a repeated question. Again, I think it is being repeated. Because we did this question just now only. Acidity of diprotic acid in aqueous solution increases in the order. Acidity they are saying. So acidity of hydrides will increase down the group. Hai na? This is the simple order only. So I think answer will be A, right? Because acidity is going to increase down the group, right? For hydrides. Then you have, which of the following order is correct for bond dissociation enthalpy of halogen? Again, I told you this is a very important order. Why? Because there will be fluctuation in chlorine and fluorine, right? Okay. So down the group, what should happen? That bond dissociation energy should decrease. But what will happen? You will see fluorine in between here, right? So answer will be B is the correct answer. Okay. Why? Because of the repulsions, electronic repulsions, right? Because of that, the bond between F and F will get really weak, right? Because of those repulsions. Next is among the following which is strongest oxidizing agent, which is a very good oxidizing agent. So down the group oxidizing agent, oxidation increases. So I2 is going to be a very good oxidizing agent. F2, wait a minute, among the following which is very good strongest oxidizing agent. F2. Strongest oxidizing agent. Wait a minute. Strongest oxidizing agent. 2Cl2, Br2, I2, right? Oxidizing agent. It will cause the oxidation, right? This I am little bit skeptical about, but yes, F2 will be the right answer, right? I'm a little bit skeptical about this, right? Because there are so many exceptions here, no? So yes. Now, then next is in which of the following arrangement given sequence is not strictly according to the property indicated against. Again hydrides, है ना? So again hydride, again the same thing, right? So acidity and reducing power will increase down the group. Firstly, so if we talk about the acidic strength, it will increase. Which of the following is not strictly? So this is so strictly according to that. This is not strictly according to that because here they are talking about pKa value, right? So answer will be B. Others are strictly according to that only, right? Others are according to that only, right? So here answer will be B, right? Next we have match the following interhalogen compound. This is what I told you, right? F2 has high reduction potential and strong tendency to accept electron. Wait a minute, oxidizing agent. That means to oxidize someone else. To increase the oxidation to oxidizing agent to reduce. Acha, okay, yes, got it, yeah. Let me tell that here. Hana, I forgot the reason only. Chalo. Thank you so much for your help. Yeah. So basically, oxidizing agent, why F2 individually is a very strong oxidizing agent. If you talk about the oxides, then oxidizing power will increase only. But if you talk about F2 individually, we know that F2 is very strong electronegativity. And if you talk about the oxidizing agent, that means it itself, and strong oxidizing agent is someone which itself will get reduced, right? Itself it will gain the electron, right? So how it will gain the electron? Because it is a very good, it has very strong electronegativity. That is why it is going to gain the electron. That is why it will reduce itself and it will oxidize the other person. So it is called oxidizing agent. Yes, so answer will be D. Yes, thank you so much for this. I was like thinking, what was the reason? Chalo. Now, this also I told you that interhalogen compound, directly they can ask you the shapes here. So basically, if you have XX, it is going to be a linear shape 1, 3, right? 1 is 3, right? XX3, it is going to be a tetrahedral shape, right? Wait a minute. XX3, XX5 is going to be definitely square pyramidal, right? So 3 is 4, 3 is 4. XX5 is going to be square pyramidal or what? XX5 is going to be, wait a minute, T shape. This was trigonal, pentagonal bipyramidal. 4 was 4. 4 was 2. है ना? XX3. It can either form tetrahedral or it can form square pyramidal. है ना? So XX3. That means 4 electron, 4 it will have, 3 bonds it will have. Halogen is having 7 electrons. It is forming 3 bonds here. So it will be left with 2 electrons also, which will form a lone pair also. So there will be one lone pair also, right? So it is going to have square pyramidal shape, not the tetrahedral shape, right? Wait a minute, I think the answer will be D. है ना? Let's see that. XX is having linear shape, XX 3 is having T shape. Wait a minute, let me draw the structure XX3. Right, if you draw the structure here, let us solve this with the help of VBT only instead of learning the structures. This is X, that means halogen. Halogen is having 7 electrons. It is forming 3 bonds here. So it will have 4 electrons that will be left. That means 2 lone pairs. So basically it is having 2 lone pairs plus it is having 3 bond pairs. So it will be 5. Right? So that means it will have pentagonal bipyramidal shape, but it is having 2 lone pairs. That is why this will be 2 lone pairs. So shape will be T shape. Okay. So it will have T shape only. Got it. Right? What about XX5? Again, solve it this way only, because yeah, there is no use of cramming this. I don't even remember cramming anything, right? So why to cram? Here you can remember this. XX7 is pentagonal bipyramidal. What is XX5? XX5 is again halogen is having 7 electrons. 5 electrons are used up in bond pairs. 2 electrons are having lone pairs. So total it will have 1 lone pair, 1 lone pair, 1 lone pair, plus you will have 5 bond pair. That means total 6. That means octahedral geometry it will have, but there will be 1 lone pair, so it will be square pyramidal geometry, right? So answer will be one is, first is linear, 1 is 3, right? Fourth is 2, 1 is 3, fourth is 2. Then you will have 2 as 1. 2 is your, second is your T shape. Yes, second is your T shape. Third is your square pyramidal shape. That is fourth. So answer is A. So this you don't even need to remember that interhalogen shapes and that table. Just do this by what I have done here, right? So I think if your VBT Vesper is clear, hai na? If you have conceptual knowledge of that, then you don't need to remember and cram these shapes here, right? So directly you will be able to answer that, right? Now, next is identify the incorrect statement regarding the molecule XCO4. Okay, so this is a compound of noble gases. They are saying that XCF4 is molecule is tetrahedral. It is square planar. 4 p pi d pi bond, and there are basically, again you don't need to cram this. Again this can be solved with the help of Vesper and hai na? So simply what you do, we know that this has, it has 8 electrons. Just give me a minute. So here you have 8 electrons. What we will do, just so sorry about that. Now here what we will see, that basically oxygen will form always double bond. Okay, I'm just drawing a rough structure here. 1, 2, 3, 4, 5, 6, 7, 8. All the 8 electrons will be consumed here, right? That means it is not going to have any lone pair here, because all these bonds will be double bond. Now, xenon is having d pi, right? And oxygen is having p pi. So it can have d pi p pi bond. So identify the incorrect statement, right? There are 4 sp3p sigma orbitals. There are 4 pi sigma bonds where you have sp3 and p sigma bonds. That is also true. Now, the main thing is whether this is a tetrahedral structure or square planar structure. So, as you can see, it is having sp3 hybridization. So, it will be a tetrahedral structure. So, B is going to be incorrect. Okay, B is going to be. So, just hit and trial method use. You can use that method and you can just draw the structure. If you have knowledge of like Vesper, VBT, then so you don't even need to cram these structures. Okay. I have just simply drawn these structures. Definitely you have to remember few structures in P block of noble gases, but these structures are very simple to draw. Okay, so from here to you can easily tell the answer, and this is also very simple structure. Here also you don't need to cram this. Okay, you can also, the method that I told you tomorrow for chemical bonding, na, just apply the same structure, because already we have a lot of cramming in block chemistry. Exceptions, right? Oxidizing power, reducing power, like too many exceptions you have here, too many trends you have here already, right? So you don't need to cram at least the shapes and chemical bonding and coordination chemistry, right? Okay, so at least now we have completed inorganic chemistry. So in the end, everything I have completed. Now guys, in the end, I'll just tell you one thing, that the inorganic chemistry, if you ask me, what is the best way to take the numbers from inorganic chemistry? See, block chemistry, so I'll tell you that I have done this so many times, inorganic chemistry, so many times I have taught, but still at one point, sometimes I'll feel like, okay, what was the answer? Okay, this was this. Same thing. Inorganic chemistry, especially block chemistry, you can't remember this for 1, 2, or 3 times. You have to make short notes. You have to make handwritten notes. You have to revise it like after every 2, 3 days. You have to revise this, right? Only then after 1 month, you will have like, you will have all like exceptions on your tips. Otherwise, though, it will go away from your head. I can like, this is either to leave block chemistry. If you want to do at least what I have done today, all the important exceptions, all the important previous year questions, do those questions, okay? If you do previous year questions, if you do exceptions, whatever I have taught you today, go through that, learn it, make short notes, revise those notes again and again. Now, easy is chemical bonding and coordination chemistry. That is my personal opinion, right? Why? Because if you are like me, like you like to know the concepts, you don't like to, because if you know the concepts behind these, right, you will be able to solve assertion reasoning questions, but you will get stuck in the exceptions. And that's why I'm telling you, firstly, the last session that I have taught you based on chemical bonding and coordination chemistry, firstly make these topics really strong, because that has very high weightage, even high weightage as compared to block chemistry. Chemical bonding and coordination chemistry has more weightage as compared to block chemistry. That's why I'm pressurizing you again and again. I'm focusing on that thing. Firstly, solve as many questions on chemical bonding coordination chemistry. I can guarantee you that uh, if you like go through chemical bonding and coordination chemistry 2 times only, na, that will be very easy for you to solve the questions. Very simple, right? Because directly, and I can guarantee that whatever question they ask you, you will be able to answer that, right? Because it is based on the same concept. In the problem in block chemistry is that either you will know the answer or you will not know the answer, right? So if you know the answer, then so you will solve this in 1 second. If you don't know the answer, then you will get stuck there, right? That is why firstly complete chemical bonding and coordination chemistry. Once that chunk is like properly you have done, don't leave block chemistry. It is a stupidity to leave block chemistry, right? Then after that, go through all the notes that I have done today, all the exceptions, right? Everything. At least if you're thinking of leaving block chemistry, go through this. It will take you maybe another 3-4 hours to go through them. Maybe on after 3-4 days, if you repeatedly study this, that will be in your head, right? Okay. Consistency is the key for block chemistry. After this, I can say that you will get really good marks in inorganic chemistry, right? But still, if you want to get full marks, then ma'am, I don't want to even take 1% risk, right? Then you can see my NCRT line by line series on NEET. I have taught, and that is same for NEET and JEE. NCRT is the same for every person, na? So you can go through that. But I would advise that if you, because see, just for 1 or 2 questions that they can ask out of syllabus, or maybe some question directly from NCRT line they can ask. Because of that one question, you study whole thing, right? That will be also a stupidity, because now you should do smart work, right? That's why I'm saying that don't get into reading NCRT again. This is not the right time to read NCRT. Not the right time. If you're like really good, like ma'am, my physical chemistry, my physics, my maths, My organic chemistry, everything is really good, ma'am. My coordination chemistry, chemical bonding, everything is, ma'am, perfect. But I'm getting stuck in block chemistry. Then go and read NCRT. But if you know that there are other chapters which will require less energy and more input, more marks you will get out of that, more output you will get out of that, then go for that, right? So that's why block chemistry I have done today. Don't leave it. Do whatever I have taught you today. Okay, as it is, right? Next is, from next lecture, I am going to start GOC, right? Now, GOC is also, I don't know why students find it tough, because GOC is also conceptual. You know, 3-4 concepts, same concept is applied everywhere, right? So GOC, rearrangement of carbocation, it's just one simple concept that is applied. Okay, so if you know GOC, 6 to 7 question you can easily expect. Okay, GOC is like 6 to 7 question easily, right? So don't miss GOC, guys. Don't miss. That will be a very big stupidity. The students who are just ignoring GOC, right? After GOC, I'm going to take up one lecture on isomerism. On isomerism also, they ask very simple questions. Isomerism of organic chemistry. Very simple questions they ask from isomerism, on geometrical and optical isomerism. Okay, so these two things we are going to do in next week. Okay, so I'll wait for all of you. Don't miss these two lectures. It's very important, very important, right? Just like I promised you that I'll complete block chemistry today. It's almost 11:45 and I'm still here because of that only, है ना? So don't miss GOC. I'm going to take up lecture at 5 p.m. because it gets really late at 7 p.m. So I'm going to take up lecture at 5 p.m. I'll tell you the day. I think it's on Tuesday, right? On Tuesday, GOC lecture will be there, as all of you were demanding for that, right? One student saying, ma'am, are you not interested in teaching JEE because your energy is not as much as teaching NEET? Arey yaar, I am teaching in 11:45 p.m. I am standing here teaching for last 5 hours continuously. He is saying that, ma'am, your energy is low. Hi Rabba, utha le re deva, utha le. Huh? What do you want from me? Should I die? Huh? I think I should die only here. है then you will feel that yes, ma'am is interested or not. Chalo. Thank you everyone. Thank you. Chalo. Okay, then bye guys. See you all in the next class. Shreya sir have class on Tuesday. Wait a minute. Let me check then. Okay, let me check that. Then when should I put my class? Okay, chalo. Modern physics. Okay, then I'll talk to Shreya sir about it when I should take the class. Means next week, GOC and isomerism we will do. Right? And again, I am saying, don't skip block chemistry. Please don't skip block chemistry. At least do what I have taught today. Right? Most probably, you will see questions from this section only that I have taught you today. Because these questions are repeatedly asked in NEET, in JEE. Right? So, please go through at least this, right? Don't skip any chapter, right? Okay. Chalo, okay then guys. Bye. Take care. See you all in the next class. Chalo. Okay, bye.